All right. I'm going to turn my camera off just because I'm switching between so many different pages. But I am still here. I'm going to share my screen, and I really just want to kind of remind you of everything that we went through yesterday, just to kind of get you back into the whole process of flight planning. Obviously, yesterday we did like the first half of it. Tonight we're going to do the second half and just finish everything up. But I want to remind you of what we did during that first half. Just because I know that most of you probably don't remember like anything from yesterday. Okay, coming back to the flight planning steps. All right, just a reminder, flight planning steps. Remember, you can find this guide in the drive under the flight planning folder, under the walkthrough folder, the second one right here. Flight planning walkthroughs. We are on the long version just so that we can see every single little step that we do. There is a simplified version that you guys will eventually look at once you do a couple of flight plans. But this PDF right here, the flight plan steps, not the simplified ones. This flight planning steps, that's what we've been following. So the first thing always is legal to go, and it's the most important part. So one thing that we will kind of emphasize when we get into in person after your quiz and after like introductions and all that stuff on Monday, we start to dig into flight plan 2. And you'll notice with the flight plans that it's like, yes, the city pair changes, yes, the times change, and you know, the number of passengers and bags change, and the aircraft number changes, and you know, all that stuff changes, but kind of the content is pretty similar, right? You still have NOTAMs that you look for, and you still, you know, pick runways, and you still do all this different stuff. The thing that changes the most is the difficulty, okay? Right now with flight plan 1, obviously we have a low level of difficulty, okay? We're really just walking everyone through the process of flight planning. Now you'll notice with flight plan 2 and 3 and 4, as you keep going, the legal to go part is the part that's going to get more difficult, okay? Because we want to introduce you to as much as possible for your practical exam, so that you feel as prepared as possible, even over prepared for your practical exam. And that's what we personally like to do as instructors. We like to try and over prepare you for your practical, just so that we try to cover as much as possible, so that you have at least seen it before you go into your practical. Okay, your practical, the DADES have different flight plans. It's going to look pretty much exactly the same. Obviously, the content's just going to be a little bit different, but the structure of the flight plan is going to be the same. So it's not going to be a surprise. You're not going to look at their flight plan and think, oh my gosh, like, I don't know what I'm looking at. Okay, they're still going to give you the most current METARs. They're going to give you the TAF. They're going to give you NOTAMs. They're going to give you the MELs. They're going to give you all the stuff that you need. And it's going to look pretty much identical to our format. Okay, they do that so really for your convenience as you go into your practicals and do a flight plan. They are not trying to burn you, all right? They want you to pass, believe it or not. And I think that's the hardest for pilots to believe. Pilots go through these check rides, and a lot of pilots experience check rides where they're just trying to burn you and they're trying to make you fail. And that is not the case with our DADES. Our DADES really want you to pass. They want to see you succeed. So they will do whatever they can, just like we try to do whatever we can to help you pass your exams. All right. So just know that flight plan 1, obviously not a lot of difficulty. We're just going through the process. But as we get into the different flight plans, they are going to grow with difficulty. And it's just for the legal to go part. This legal to go part, again, the most important part. And you guys will meet Adam in person if you haven't met him in person already. But if you'll meet him in person, and he loves to harp on this legal to go, because it really is the most important part of everything that we do as dispatchers. Legal to go, it becomes second nature to us. Everything that we check every single time with each flight, and we check it multiple times per flight. So that's why we focus so much on it, okay? And that's why we require you guys to get 100% on your legal to go quizzes. I'm pretty sure Jaden posted part of that as well, is that we focus so much on it because once you go into assessment tests and interviews and even ground school, after you get hired, once you go into ground school, pretty much the whole focus is legal to go and making sure that you can look at a TAF and recognize that if you're legal or not. Okay. Yeah, go ahead. Was there a question?
That was Kyrie's note taker.
Oh, okay. Thank you. Yes, Kyrie told me that he wouldn't be able to log on tonight. And so I'm not surprised that his note taker is on. Okay. So first step and the most important step always is legal to go. Because if we are not legal to go, then we're not even going to even go into any of the other stuff, right? We're not going to worry about building a route. We're not going to worry about weight and balance. We're not going to worry about performance, like picking a flight level and going into ISIN performance numbers in the IFR flight plan, if we can't even land at our ETA. And if we are not legal to go in general, we're not going to do any of the additional stuff. So we did legal to go last night for Denver to Salt Lake. Remember, we had to find our ETA. So we went to SkyVector and just got that direct distance from Denver to Salt Lake, because at that point we had not built a route yet. So we just got that direct distance. We padded it by that 10%, multiply it by 1.1. And then we divided that by 400, because 400 is our average rate of speed, 400 knots. And that gave us our ETE, which was 56 minutes, right? Short flight, just over the Rocky Mountain Range, short flight. That 56 minutes, remember, we went through the process. It gave us a decimal when we did this calculation. It gave us a decimal. We just multiplied it by 60 to change it over to minutes. And then we added that 56 minutes to our departure time, and that gave us our arrival time, our estimated time of arrival. And again, I cannot emphasize this enough. Use a time calculator. Please do not do it in your head. You guys are really, really smart, and I know that. I do know that, but please just use calculators. Okay, after that, we went into our destination airport because we found our ETA. We picked a runway, right? We went into the jet charts and went to the 10-9 chart. We looked at the runways. We picked a runway that matched up with a headwind, and it was the longest runway available. And then we went into the NOTAMs. So like I said, some people, they like to go through their NOTAMs first and then pick a runway and then go back through their NOTAMs. If that's what you want to do, that's fine. I prefer not as much work. So I prefer to pick my runway first and then go through my NOTAMs to see if there's anything that affect my minimums, okay? And then I find my minimums from the jet chart. Obviously, you guys have done that a lot. And then, of course, legal to go, like looking at the TAF for our ETA. Again, remember landing minimums, right? We're only looking at visibility. Only visibility is required, okay? We also asked ourselves, we did the 1, 2, 3 rule, if we needed a destination alternate, which we did not for Salt Lake. We then went into the charts for Denver, right? We picked a runway for Denver. We checked the NOTAMs for that runway or for anything that might affect our takeoff or landing minimums. And we found our takeoff and landing minimums in the JEP charts. For one, we needed to make sure that we could take off, which we definitely could because the visibility is great in Denver. And then we asked ourselves if we needed a takeoff alternate, right? We looked at that METAR. We had 10 statute miles of visibility, which is great. And we did not require a takeoff alternate. So we didn't have to go through this next section of alternate selection. You will go through it, don't worry. But just for this specific flight plan, we don't require any alternates. And so we didn't have to go through this alternate selection section in here. We checked to see if we had any MELs, which we did not. Remember, the MELs would be at the very bottom of your flight plan packet, right after the winds aloft. We didn't have any MELs, and so we don't have any restrictions, MEL restrictions for our flight. And that's the main thing that we have to look at with these MELs. If we only have one MEL, then we look at those restrictions and say, okay, does it affect my flight at all? Does it affect my flight level, right? And it will tell you right on the MEL. It'll say like restricted to or limited to flight level 270 or 280 and below. Restricted to flight level 320 or below. Okay, it'll tell you right on the MEL. But we did not have any restrictions. We don't have any MELs for this flight plan. So remember, I actually just texted Jaden, like 10, 15 minutes ago. I was talking about this specific page and I said, is there any way we can get flashing lights, blinking lights around this section right here? He started laughing. He's like, I'll look into it. So for now, I will just put this cute little red box around it. If you find any problem at all, just stop and talk to an instructor or the DAID about it, and they're going to tell you how to proceed. Okay. I harped on it last night. I'm not going to again. Just going to remind you, if you come across any problems, just stop. Talk to an instructor about it. Okay. After that, we filled out that form, the takeoff destination alternate requirements form. It was this next form right here. So we put in all the information about Denver, all the information about runway 16 right for takeoff minimums, right? And then we came down and filled out the destination portion of it for Salt Lake. We put in our ETA that we had found, and this weather is from the forecast, right? From the TAF. So the weather that we are planning on. And then all the information about the runway and the approach for that runway. What approach are we planning on using? We didn't have any alternates, so we got to skip those two parts. But that was this step 2 right here. Okay. Went through that. Again, if you need to, you can reference the dispatch release reference guide. That will show you exactly where you pull all of this different information. And that's in that the walkthrough guide folder that we looked at. Next, we built the route, right? In SkyVector, before we built the route, we only had Denver to Salt Lake in here. Right, we only had the city pair in there to get that direct distance, but then we actually came in here and put in a SID and then put in a star. So remember, again, you can come back here and it'll tell you the process of building a route. Pick a SID, pick a departure, and remember, when you are looking at the JEP charts, when you're looking at the SIDs, find the departure that goes in the direction your route is going. Okay, make it make sense, right? Find the SID, find the star that make the most sense. So again, pick an arrival. You find an arrival for your destination that goes in the direction your route is going. Just really quick, just last class, we had a student, for some reason, he wanted to burn as much fuel as possible. And so when he was building his routes, and I don't know if it was intentional or not, he was, trying to do his best and make it make sense in his head. But he would build a route that would come like totally out of the way. And he would build a complete route, but we had to just kind of hone that down and say, okay, can we make it any more direct? Can we burn less fuel, right? The airline that you're going to get hired at, they're going to talk about fuel. And they're going to talk about fuel consumption and fuel policies and how can we be more efficient. So it was a good learning experience. Normally we don't have students who try to burn as much fuel as possible. So it was a good learning experience for all of us to talk more about, hey, let's find stuff that makes the most sense and find the most direct route possible. Okay. So that's what we did last night with building a route. We found a SID out of Denver that made the most sense, right? We were heading towards the west. And then we went into the jet charts for Salt Lake and we picked a star that came from the east. And then we connected those two together. And it ended up being connected with the same exact transition point of Meeker. So we built our route, and beautiful, beautiful, simple route going from Denver to Salt Lake. Beautiful. Okay, weight and balance. Pretty straightforward. I know that you guys have seen it a few times now. So weight and balance. Remember that weight and balance sheet. Let me go back up to it. Probably the most simple part of doing all this flight planning stuff. It's really just, filling all this portion out. The hardest thing, honestly, for people is finding your Minto, finding your fuel. So remember, we had to figure out the fuel burn and then any alternate fuel and then reserve fuel. Reserve fuel is always 2,500. With that burn, with the regular burn, remember we had to go back to the weight and balance and fuel calculation page. So weight and balance, fuel calculation. The fuel calculation is the last two steps. So step 4, to calculate your fuel burn. Remember, the first hour is always 4,000 pounds, and every hour after that is 3,000 pounds. So with this example, okay, it uses Denver to Salt Lake. So finding out our fuel burn, we take that first hour of 4,000 pounds, we divide it by 60 because that gives us the fuel burn per minute, okay? Because we're not flying for an entire hour, we're flying for 56 minutes. So we have to find that fuel burn for 56 minutes. So we divide that 4,000 by 60, that gives us the average fuel burn minute of 66.6. And we take that and multiply it by how many minutes we are flying. So we took that, multiply it by 56. That gave us 3733. And remember, with fuel, okay, specifically with fuel, we always round that value up to the next whole number. Okay, so even though it was 0.3, we rounded it up. So 3734. That was just our burn. And then going into our reserve and our alternate, we don't have an alternate for this specific flight plan, but our reserve is always that 2,500 pounds. And so we added that 3734 and 2,500, and that gave us 6234 for our Minto. So that's usually the most difficult part about weight and balance, is just figuring out the fuel calculation. Everything else, you're just filling in all these different numbers, finding the different weights on the different sides of this page. And then remember the passenger index. We had to go to the pin chart. Remember the very, very last page, the pin chart here. We loaded from the back to the front. We went to the performance charts to find all of these different indexes, right? Let me come back to the performance charts. Passenger index table. And there we go. we found all of these indexes for the different zones and how many passengers we had in each zone, right? So we filled that out. We got our total index of negative 25.5. Coming back to the weight and balance, we just kept going. We added all of these weights together to get our zero fuel weight. And then we added the indexes together to get to the zero fuel weight index. Okay. Then we add in the fuel. We already did our Minto, and then we found our fuel index. And then we get to our takeoff weight and our takeoff weight index. Okay. We then had to find our landing weight. And remember, there were two different ways to find your landing weight, and it really is just personal preference. Okay. I usually start at the zero fuel weight right here, 57,982. And I think, what fuel am I landing with? Right. Well, I'm landing with any alternate fuel and any reserve fuel, because my burn fuel, I'm just going to burn it off. So I am thinking, okay, what do I have for alternate? I don't have an alternate. What is my reserve? My reserve is always 2,500. So there is my landing weight. I'm landing with the weight of the aircraft, the weight of the passengers and the cargo, and the weight of the remaining fuel, which is the reserve fuel and any alternate fuel. So I personally like to start at the zero fuel weight right here and just add whatever fuel I'm landing with. But some people, you'll notice with other instructors, they like to start at this takeoff weight and just subtract the burn, which is totally fine. So 64,216, and we subtract that 3734 for that burn, and it gives you that landing weight. Okay. Now, the reason why I like to start at zero fuel weight is because when you get to this landing weight index right here, your starting point is always the zero fuel weight index number. It's always the same. That's always your starting point. Okay. Because then you have to think again, what fuel am I planning on landing with? Well, I'm planning on landing with alternate and reserve fuel. So in this specific situation, I'm planning on landing with 2,500 pounds. So 2,500 pounds, the fuel index for that is that negative 1.5 right here. And I always have to come back to the zero fuel weight index and subtract that index right here, that negative 1.5. And that will give me my landing weight index. Okay. So in my mind, it makes more sense to just keep it consistent, but it totally works both ways. Okay. To find your landing weight. If you want to start at takeoff weight, that's fine. If you start at zero fuel weight, that's fine. Whichever way you prefer. All right. And I know that right now it's like you don't really know, any difference. Next week, you are going to, you're just going to get in your own groove. Okay. And you're going to notice that these, little things like this, we're not going to say, oh, hey, don't do it that way. Do it this way. Every dispatcher dispatches a little bit differently. Ultimately, we get to the same goal, right? Is it legal to go or not? We plan a flight, but you have that operational control over that flight. And so we really help you focus in on that, your operational control. We teach you the process of flight planning, but as you get into the more difficult flight plans, yes, we make sure that you find the problems with it. But as far as like planning the actual flight and doing performance numbers and all that, everyone's going to do it just a tiny bit differently. And we are totally fine with that. Okay. We don't want to just pop out cookie cutter dispatchers. We want to teach you the correct way of doing legal to go and finding all of these different things and knowing the process, but we're not going to just pop out robots. You guys are people, you guys are smart, and you guys are learning this process, and you guys are going to flight plan just a little bit differently. Okay. So that's why I always say to find your landing weight, there are two different ways, and you can just pick one. Either one works. You get to the same answer. Okay. After that, we graphed it out. And again, remember, let me come down here. That last part of weight and balance is graphing it out. So you graph out your zero fuel weight and index, your takeoff weight and index, and your landing weight and index, because you make sure that you're in balance and within your weight limitations. So we graphed it out with a T, L, and Z for takeoff, landing, and zero. We made sure our letters were in this central location right here. And you can always double check your weight limitations over here on the side. Okay. This first line right here, the central line, is max zero fuel weight of 62,300 pounds. This next line up here is max landing weight of 67,000 pounds. And then this second to top line, you just have to look at it a little bit deeper, but the second to top line is your max takeoff weight of 75,000 pounds. This very, very top line over here is your max ramp weight. And that is just your max takeoff weight plus your taxi out fuel. Okay, so 250 pounds of taxi out fuel. All right. So if you ever get into a situation where you forget one of these max weights, guess what? They're listed right here. Okay. So this is a good way to just double check ourselves. Okay, this max zero fuel weight line of 62.3, we want to make sure our Z is below this first line right here. The second line, we want to make sure our L is below this line. And then of course, this second to top line, we want to make sure our T is below this top line right here, okay? This is why we graph it out, to make sure that we are balanced enough to take off. So I have a little story for you, and I'm pretty sure I told it to you the very first time we looked at weight and balance. When I was taking my actual practical with my DADE, they created a problem for me, which they might actually do to you, okay? So you'll have problems that you'll come across with your flight plan, but they might actually be problems that the DADE creates in the moment, okay? So my DADE created a problem in the moment when I was doing my pin chart right here. I was working on my pin chart. I put my adults in and I put my children in right here. And then before I started to load any of them, my DADE stopped me and said, here, I want you to load this many passengers in zone A and zone B, zone C, zone D, zone E, and zone F. She told me where to load my passengers. And of course, she loaded it from the front to the back. So I knew that I would probably have a problem, but I had to show her that I could recognize that problem, okay? So I did it her way. She gave me the parameters of the flight plan. So I followed those parameters and I loaded the passengers how she wanted me to. I got my index. And then when I came back up to the weight and balance page and I started putting everything in, when I got to the graph, my letters right here, they were all the way over here on this far left side. Okay. So this is why we graph it out. So all my letters were over here. So I stopped and I said, I have a problem. And she said, okay, what is your problem? And I said, I am too nose heavy and I cannot take off. And she's like, okay, well, what's your solution? What do you need to do about it? And I said, I need to load the passengers from the back to the front instead of from the front to the back. And she said, okay, go ahead. So I came back to my pin chart. And again, this is why we work with pencils, not pens, okay? I just erased the passenger numbers here in these zones really quick. I reloaded them from the back to the front. I fixed my index numbers over here. I got my correct total index. I went back to the weight and balance page. I just fixed, all I really needed to do was fix the index numbers after that, okay? And then I came back and I regraphed it, and guess what? All of my letters were right smack dab in the middle like this. So you may or may not have that during your actual practical. Okay, it totally happened to me 5 years ago. So, and I've heard just from the past year, I've heard from different students that they actually had that during their practical. So a few of you might be the lucky ones where they tell you where to load the passengers. And you do it because they give you those parameters, and then you recognize the problem. Okay, you recognize the problem and you just stop and you tell them what's going on, and they ask you, right? She said, okay, what do you need to do about it? And I just simply said, I need to reload my passengers from the back to the front. And she just said, okay, go ahead and do it. Okay, so it's as easy as that. When you find a problem, just stop, take it to your instructor or your DAID, and tell them what needs to happen. And then they tell you, okay, go ahead. Or they'll say, actually, we're going to do it this way. Okay. So, but this is why we graph it out. Want to make sure that we're as balanced as possible. Remember, the last part of this was finding our MAC percentage right here. So we find the T, that takeoff weight and index. We find our T, we go straight up from it, and we just go to the nearest number on here. Okay. Most of these are odd numbers, and you'll see when we get to the takeoff stab trim setting that that they follow these specific numbers. So even if your T it feels like it's like right smack dab in the middle, just go to the nearest one or pick one. Okay. Don't think, oh, this says 23 and this says 25, so I'm going to put 24. Don't do that because on the table for the takeoff stab trim setting, there is no 24 on there. Okay. So just go to the nearest number, put that percentage in there, and that is one of the very last steps on our release. So there's weight and balance, just filling it out, graphing it out. And guess what? Now we are going to do the rest. We are now going to pick a flight level. Okay. And before we go into this, are there any questions that you guys have about everything that we've done so far? Everything that we did yesterday?
I have a question. It's not really about what we did yesterday, just more so for the practical. When
Okay.
we're going through the flight release, are we talking them through like what we're doing step by step? Or is it kind of just you're staying quiet and every time you finish something, they're checking it?
That is a great question. Let's just say this. The more that you think out loud, the less questions you're going to have from them. Okay?
Okay, that sounds perfect.
Okay. So if you are going through your, even just weight and balance, and you're talking about it to yourself out loud, then guess what? They know exactly what you're thinking. And so they're not going to ask you that many questions about anything because they've been following your thought process. So if you're like me, I don't really think out loud that much. And it was really hard for me to like consciously do that. But I really had to push myself. It's like I got to my weight and balance. I'm like, okay. And I just had to like say it out loud to myself, right? It's like, okay, I have 52 adults. I have 12 kids. That's 64 total. Let me go find my weight for my adults. And really just talking through the process out loud. Guess what? I didn't get any questions about weight and balance because she knew exactly what I was thinking through the entire process. And it's like I got to my graph and I'm like, okay, now I need to graph it out. I do my graph and I'm like, oh, hold on, I have a problem. And she's like, oh, okay, what's your problem? All right. So all of us will tell you this. The more that you guys think out loud and just kind of talk to yourself about it, the less questions the DAID will have to ask you. All right, about your flight plan. So you might be like me where I just don't talk, I don't think out loud. So it was really, sometimes it was really difficult for me, like when I was going through the flight plan. I really had to like remind myself. It's like, oh, say this out loud. It's like, oh, I have a NOTAM for this ILS for 16 right out of service. Let me see if it affects my flight. Right? I had to remind myself to do that. So just that might be, you might be like me where it was kind of difficult, but there you go. Just think out loud and you'll get less questions.
Hey, Allison,
Yes.
on that same note, are they, I mean, are they going to be like literally watching your paper as you write things down, looking over your shoulder, or are they just kind of, because I got to say, I don't do well in that kind of situation.
Me neither. And no, they are not going to watch your every move.
Okay, good.
They're going to be sitting across the table from you, and they're just
Okay.
going to be observing you. They're not going to be watching every single little thing that you write down. They're not going to be breathing over your shoulder. Okay.
Thank you. That's good. Because I was a software developer in my past life, and if any situations where they had like us like teaming up to code and stuff, I just like, just leave me alone. Come back in 20 minutes. I'll have it for you. So
I get it. I totally get it.
Yeah.
So yeah, they're not going to be hovering over you.
Cool.
It's like they're just observing, right? They want to make sure that you understand the process of flight planning. They want to make sure they're going to be watching you just, go through your NOTAMs and making sure that you're seeing everything. Like, but also like this is where thinking out loud helps you, is because they know their flight plans. They created their flight plans, so they know all the different problems with each flight plan. And they are going to, if you talk out loud and you recognize those problems and you say it, then they're just, it's kind of like a check mark for them saying, oh, okay, they got that problem. And oh, okay, they found that problem and that problem and that problem. What, however many problems you have for your flight plan. It's like, they're just going to be observing you. Okay.
Yeah.
My flight plan, honestly, I only had 2 things that I needed to do, and that was it. Other flight plans, they're like 4 or 5 things. Other flight plans, they are not legal to go at all, right? So they create their own flight plans. We are not in charge of that. This is why we try to introduce you to as much as possible. Okay, we try our best to over prepare you, just so that whatever you get in your flight plan, you will have seen it by then. Okay.
Great. Thanks.
But yeah, they're not breathing on your neck. Don't worry about that. Any other questions up to this point?
Allison, I have a question about the weight imbalance.
Okay.
What's the note? I think it says like area A on the graph in the box.
Okay, so area A, it deals with this note over here. Okay, so when the takeoff weight and index or zero fuel weight and index fall in area A, verify by visual inspection that the passengers are evenly distributed about the passenger zone. So this is where I was talking about my letters were over in this area over here. If they are in area A or further, then it's saying, okay, now you need to move your passengers around. You need to distribute your passengers a little bit more evenly. Okay.
Okay, got it. Thank you.
All right. So again, this is why we graph it out. If any of you have been on the CRJ 700 or even on a CRJ in general, just the smaller regional jets, and either the captain or a flight attendant came out and said, hey, we need somebody from row 2 to move to row 10. This is exactly why. Okay, just for the weight and balance. And they really only say, hey, we just need you to move to row 10 for takeoff. And then after we get, out of sterile or out, past 10,000 feet, then you can move back to row 2. Okay. It happened so many times when I was working at SkyWest. And it's like I knew this, and so every time, I was non-revving, I was flying standby, and anytime a flight attendant came back into the cabin and said, "Hey, we need somebody to move from the front to the back," my hand was one of the first ones to go up because I knew if nobody moved, we were not taking off. So it's like I didn't even care. I was just glad to be on the plane. I was glad to have an open seat for my butt. And I knew that if no one moved, which people don't want to move, right? They paid for their seat up front. They want to sit up front. They don't want to move to the back of the airplane. It's like, I don't even care because I know that if you don't move or if I don't move, then we are not leaving. We're not even pushing back from the gate. So there was one time, I don't know if I told you guys that story. I think we were in Denver. I think I was going Denver to St. George. I was seated in row 1, and the flight attendant came back and said, "Hey, I need somebody from row 2 to move to, at least row 10 or 11. And no one in row 2 wanted to move, of course. Row 2 was full. It was like that there, both sides of the aircraft, it was like there was a couple. And none of them wanted to move. And she just needed one person. She needed one person to move from the second row to the back of the airplane just to take off. None of them wanted to move. And so I finally looked back and I said, "Does somebody want to sit up here and I'll go to the back of the plane?" And no one wanted to take my row 1 seat just to take off. And it's like, I finally just told them, I'm like, "Hey, we're not taking off until one of you moves. And so if you want to sit in my seat, then I'll move. I don't care." And anyway, one of the passengers in row 2 finally, he was very distraught about it, but he finally just got up and went to the back. And it was only to take off. That's all it was for. The flight attendant looked at me and she's like, "Thank you very much for understanding and thank you for being willing." But just those situations, you guys will experience it if you fly on those smaller jets. Okay, these smaller jets are great. They are just nose heavy. So this is why we graph it out. And obviously for that specific flight, we were in area A. And so we just needed to move one passenger to be able to get in this central location right here. Okay.
Hey, Allison, along those same lines, could you tell me again how you divide the number of passengers up into the different zones?
Yeah. So on this pin chart.
Yes.
Okay. So with this pin chart, it actually tells you in the parentheses here, the max amount of passengers in each zone. So loading it from the back to the front, I just loaded the max amount of passengers in each zone until I needed to change the number to equal out to 64. Okay. So 10 in zone F, 12, 12, 12, 12. There was 48 and then 58. And I just needed 6 more passengers to equal 64.
So you're always going to max out back to front until you start having
Until you just need to equal out to your total passenger count. Yep.
yeah, and then you have, once you're at a discretionary number, then you just sort of average that until you get to the front.
Yeah, so just fill out the max amount of passengers until you don't need to.
Okay.
Okay. Yep. And it's like during my practical, she was saying, "Okay, I want 12 in zone A, and I want 7 in zone B, and I want 10 in zone C." And she was telling me specific numbers for each zone. And so immediately I'm like, okay, I'm going to have a problem with this, but I'm going to do it her way until I can show that I recognize the problem, right? So they may or may not have you do that. But until then, for all your flight plans, just put the max amount of passengers in each zone from the back to the front to really just equal out to your total passenger number, your total pax. Okay. Any other questions? Great questions, guys. Any legal to go questions? Or even questions with building a route?
I was feeling kind of saturated last night. I'm hoping that it'll make more sense once we're sort of doing it in person.
Yes, it will make so much more sense in person. So even tonight, like it's going to feel even more saturated because now we're going to go into ISA and we're going to go into the IFR flight plan with performance numbers, and the performance numbers require more calculations. So it's like it's going to feel even more by the end of tonight, but as you do it in person, it's going to make so much more sense in person. When you guys get here to St. George, it'll just click. All right. And I promise that. I promise it will just click and you'll just start to connect the dots for everything with flight planning. Okay. All right. We need to, oh, sorry, went past it. We're going to pick a flight level. But before we do that, let's just take a break. I wanted to remind you guys of everything that we've done so far. And so now let's just do, are you guys good with 30 after the hour? So 7-8 minute break? All right, come back at 30. Okay, let me know when you guys get back. I'm gonna jump back into this. Okay, now we are going to pick a flight level. So with picking a flight level, to be able to do that, we use the flight planning altitude selection chart, it's a mouthful, to determine the max altitude that we can reach, okay? So we are going to select an even or odd flight level based on the direct heading from our departure to destination, right? West, we are going to be on an even flight level, and then going east, we go on an odd flight level. All right, so this flight planning altitude selection chart, this is in the performance charts. And let's get back up to the table of contents. It is your altitude capability chart right here. Okay, you know, right? Makes sense. Altitude capability. So when you're picking a flight level, you are figuring out what altitude you are capable of reaching for your flight. And this is the table. This is what it looks like. I'll zoom out so you can kind of see the entire thing. But this is our altitude capability chart. So with this table here, obviously we have this top row, okay? And this is our deviation from ISA. And then the side column over here, which is our weight, our gross weight. So again, we are taking off to a certain altitude. So this is going to be our takeoff weight. And we just figured that out with our weight and balance, right? Our estimated takeoff weight, which is 64,216. All right, so 64,216. Really quick, I'm just going to come over here and put that in there, because we are going to get to this part. But 64,000, over 64,000 pounds, right? So on these performance charts, we have all these even numbers over here. Well, we are already heavier than 64,000, right? We are 64,216 or something like that. So because we are already heavier than 64, we are going to go down to 66. So this is the row that we're going to be looking at right here. But now we have to figure out what is our deviation from ISA? Not just regular ISA. We have to find out our ISA deviation. So now we are going to jump into ISA deviation. Yay! I know you guys will love ISA as much as I love it. Hopefully. And if you don't, then you're like a normal person. Okay, ISA deviation. We're going to come into these walkthrough guides again. And it is the second to last one, okay? ISA and ISA deviation. This is what it looks like. And it, again, it walks you through every single part of finding ISA first. And then the second part is finding your ISA deviation. All right. So I already have it opened here because we are going to, I'm going to type out some numbers as we figure out our ISA and then our ISA deviation. So first of all, we are taking off from Denver, right? So Denver is our starting point right here. That is our starting airport. Okay, so now, first of all, our first part, or our step one, we are going to correct ISA for elevation change. Remember, who remembers what ISA stands for? ISA. What does ISA stand for? I can't see your hand, so somebody just talk.
International Standard Atmosphere.
Perfect. All right, now what is ISA at sea level?
Fifteen degrees Celsius.
Perfect, thank you. So ISA, we have this international standard atmosphere, right? Now, they created it for a common reference point, right? A standard to always come back to. So ISA at mean sea level is 15 degrees Celsius. Mean sea level, wherever you are, the mean sea level is going to be 15 degrees Celsius for ISA. Now we think of the standard lapse rate. What is the standard lapse rate? And don't look at this page because it actually tells you. What's the standard lapse
2 degrees Celsius
Per
per
1,000
1,000 feet.
Yeah, 2 degrees per 1,000 feet, right? 2 degrees Celsius per 1,000 feet, meaning as you go up in elevation, the temperature is going to decrease 2 degrees Celsius per 1,000 feet as you increase in elevation. Okay. So because of that, what we have to do is we have to correct ISA for the elevation change because Denver is definitely not at sea level. Right? Denver is the Mile High City. So it definitely is not at sea level elevation. So what we have to do is we have to correct for that elevation change. So with our airport elevation, so Denver airport elevation, we are going to find that elevation. And remember, like, I'll just read this really quick. Find the airport elevation off the JEP chart, or use the flight level from the closest flight level from your winds and temps aloft. So flight level, we're not up in the air yet, right? We're trying to take off right now. So we are going to use the airport elevation off the JEP chart. Now, when we get up to cruise, that's when we would use a specific flight level, okay? But for climbing, for descending, into our airports, in and out of our airports, we use the airport elevation. All right, so there's our first step. For Denver, we need to go to the JEP chart to find our airport elevation. JEP charts for Denver, and you don't even have to go past this first page right here because it gives you this airport elevation. 5,434 feet, 5434. That's why it's called the Mile High City, okay? 5434. Now, you guys know that I forget everything. So I'm going to write that down. 5434, there is our airport elevation. All right, next bullet point. Round that value, right, the 5434. We're going to round that to the nearest 500 for that airport elevation. Now, if we were up in the air, we wouldn't need to round it all. We would just use the actual flight level. Okay, so that's what this part means. Round to the nearest 500 for the airport elevation, or just use the actual flight level. So 5434, we're going to round it to the nearest 500. Right? Example, 500, 1,000, 1,500, 2,000, 2,500, etc. So 5434, we're going to round it to the nearest 500. So that would be what?
6,000? Oh no. Oh,
5,500, right? To the nearest 500. So it's either 5,000 or 5,500. Okay, so 5,500 right there. Now,
Are you always gonna round up for that?
Some people like to say, yes, always round up because a higher elevation is going to be more restrictive, right? You're going to get to some airports that are only at like 13 feet elevation. If you want to round that all the way up to 500 feet, you're more than welcome to. If you just want to round it to sea level, I mean, that's what I would do. And you could actually do it both ways, and you would see that it really doesn't make that much of a difference. Okay. So in this case, we're just rounding up to 5,500. If the airport elevation were like 5,100, I personally would just round it to 5,000. So again, this is more of it gets into, you know, your personal preference. If you want to round up, round up. If you want to round down with this elevation. Okay.
quick question, Allison. If you
Yes.
have 5,634, let's say, would you bring it back to 5,500?
I personally would.
But would it
I-
not take you less? I'm not like sure if it's gonna be so much of a difference with the elevation. With the 100.
You know what? I'll show you.
Okay.
Okay. I'll show you. Let me get through this and then I'll show you kind of how it doesn't make that big of a difference. Okay.
Sure.
Okay. So 5,500 here, our next bullet point. We're going to take our elevation and we're going to move the decimal point over 3 places. So 5,500 now becomes 5.5, right? We're moving the decimal place over 3 places. So for example, 8,000 becomes 8, 38,000 becomes 38. Now, remember we have to consider the standard lapse rate. So we are going to take this 5.5, we're going to multiply that value by 2 because that standard lapse rate is 2 degrees per 1,000 feet. Temperature decreases by 2 degrees as you go up in elevation. So we're going to take 5.5, multiply it by 2. And that equals, use your calculator if you want, 11 degrees Celsius. Okay. Now, the next bullet point. Subtract that value, right? This new value of 11. Subtract that value from 15 because ISA at sea level is 15 degrees Celsius. So we take 15 minus 11, and that equals 4 degrees Celsius. The answer is the temperature ISA should be at that elevation or flight level. So at 5,500 feet, ISA should be 4 degrees Celsius. Okay, should be. That is ISA. We just figured out ISA for Denver. Now, the next step is finding ISA deviation. Okay, so we know that ISA should be 4 degrees Celsius. We just figured that out. Now we're going to see how far we are actually deviating away from that 4 degrees Celsius. So to do that, we identify our actual temperature in our METAR. So we're still on the ground, right? So we get that METAR for Denver. If we were up in the air, we would look at winds and temps aloft. We are not aloft right now. We're on the ground. So we look at that METAR. So for Denver, we're going to look at the actual temperature in the most current METAR, which is 18 degrees Celsius. A little warm, a lot warmer, right? So 18 degrees Celsius, the actual temperature. Now take your ISA temperature you saw for in the first part, which is 4, and we're going to find the difference between these two numbers. Okay. So from 4 to 18, that's a difference of 14 degrees Celsius, right? Now ask yourself this question. Is your current temperature, 18 degrees Celsius, is that warmer or colder than what ISA should be of 4 degrees Celsius? If your current temperature is warmer than what ISA should be, then the answer is ISA plus. If your current temperature is colder than what ISA should be, then the answer is ISA minus. So in this example, ISA should be 4 degrees Celsius, right? But our current temperature is 18 degrees Celsius. So we are getting warmer by 14 degrees. There's a 14-degree difference between these two numbers. And from 4 to 18, we are getting warmer. So the answer is ISA plus, get the mouse out of the way, 14 degrees Celsius. That is our ISA deviation. We are deviating 14 degrees warmer than what ISA should be. Okay? ISA plus 14. Okay, now I want to show you really quick let's go to, we're going to just do this other example really quick, okay? 5,000, right? So let's say we decided to round down. So 5,000, we're going to move that decimal point 3 spots. So 5,000 becomes 5. We're going to multiply that value by 2, right? That equals 10. We're going to take that value and subtract it from 15. Oops, sorry. Okay, come on, Allison. And that equals 5, right? 5 degrees Celsius. All right, now with rounding down, our temperature, our ISA, should be 5 degrees Celsius. Well, our current temperature is 18 degrees Celsius. So from 5 to 18, we are now ISA plus how many? 13? Right? So if it's supposed to be 4 degrees Celsius, we are ISA plus 14. If it's supposed to be 5 degrees Celsius, we are ISA plus 13. Now, with going to your performance charts, okay? You see these deviations from ISA up here? Do you see a 13 and a 14? No, we don't, right? The closest numbers we have are 10 and 15. Because those are the ISA charts that we have, right? The ISA, the deviation from ISA, we have ISA plus 10 or plus 15. Well, which one are we going to choose? We have,
They're closer to 15 for both.
why? Why 15?
They're
Because,
closer than 10, the 13 and 14.
okay, don't think of it as being closer, think of it as being warmer.
Got it. Okay.
Okay, so warmer in this with choosing which column we look at, you're going to start hearing my voice in your dreams saying, always go warmer, okay? Because it's more restrictive. So this is why I wanted to just kind of show you, oh, let me go, oh, where are we? Right here, sorry. This is why I say it doesn't make too much of a difference, because in either case, we are still going to use the ISA plus 15 performance. Okay. Both ways, if we rounded up or we rounded down, we would still land on this 15 column. Okay.
So even if we got like the ISA deviation as 11, we
We
would
would still go to 15.
since it's
Yep.
warmer. Okay.
So even if you have ISA minus 1, or even ISA minus 9, you would still go to 0, because 0 is warmer. Okay. Great questions with rounding. And again, this comes back to if you always want to round up, then round up. If you want to round to the closest 500, round to the closest 500. Ultimately, most cases, it really doesn't make too much of a difference because you are utilizing the same ISA chart. Okay. All right. Okay. So we did both examples. So Denver, we just found the ISA deviation for Denver, and ISA plus 14 or even plus 13. Just going back to this altitude capabilities chart, we're going to use this 15 column. We already know that we are heavier than 64,000 pounds, so we're going to go to 66. And guess what? There is our altitude capability. This is saying at your takeoff weight from this elevation, and with everything functioning how it should on your aircraft, you can get all the way up to 38,957, which is pretty high. Okay. 38,957. Now you have to think, okay, which direction are we flying? From Denver to Salt Lake. Which direction are we going?
West.
West. So going west, are we going to be even or odd?
Even.
Even. West is best, right? All right, the East Coast is full of oddballs, and I'm allowed to say that because I live on the East Coast. So just remember that west is even, east is odd. So this is saying our max flight level, right? Our max altitude is 38,957. Well, we are going at an even flight level, so we are going to be limited to 38,000 feet. That is our flight level. Okay. Now, if we were going east, we would be limited to 37,000 feet. Because this is our max, we wouldn't be able to get all the way up to 39,000 feet. So we would be at 37,000 feet if we were going east. Okay, so 380, that is our flight level. Now, in reality, would we get all the way up to 38,000 feet going from Denver to Salt Lake? No, absolutely not. In reality, we'd probably get up to, I don't know, maybe 34,000 feet. Usually you'd probably be at 30,000 feet, maybe 32,000 feet. But remember the flight planning steps. The flights going west, choose the highest even flight level. Okay. If you want to just keep it simple, just go with the highest even flight level that you can do when you're going west. According to our performance chart, we can get all the way up to 38,000 feet. So let's just go with it. We'll go with 38,000 feet since we're capable of doing it, right? So on this IFR flight plan right here, I'm just going to start filling it in because, again, it's just, you know, repeating yourself over and over again. Our aircraft number was that 748 Sierra Kilo. Captain, obvious. And dispatcher is the class. We're all doing this together. I don't care what name you put for your captain. You might get brownie points if you put Captain Allison. You might not. Our alternate, we don't have an alternate, right? We don't have any need for an alternate. Our flight level is 380. And then I had already put in our filed route right there from yesterday. Okay, we just picked a flight level. We can go all the way up to 38,000 feet. All right, now the next step is determine ISA for departure and destination. Well, guess what? We just figured out ISA for our departure because we had to do it for Denver. So now we need to do it for Salt Lake. So now we're going to go through the same exact process. I'm going to delete some of these so that you... I'm going to keep that one up for Denver. And I'll move this one over here. Okay, now we're going to do Salt Lake. So rinse, wash, repeat. We're going to find the airport elevation off the jet chart for Salt Lake. Okay, just right on this front page, 4,231 feet, 4231. That is our airport elevation for Salt Lake. 4231. Now, this is a good example, okay? Round to the nearest 500, right? Well, 4231, that's pretty much right smack dab in the middle. Are we going to go with 4,000? Or are we going to go with 4,500? What do you guys think?
It says nearest, so let's do 4,000.
Okay, we can do 4,000. All right, so 4,000. Now, the next bullet point, we're going to move that decimal point over 3 places. So 4,000 becomes 4. Now we are going to multiply that value by 2. And that becomes 8. And then we're going to take that value, we're going to subtract it by 15, from 15. So 15 minus 8 equals 7. Okay, so at 4,000 feet, ISA should be 7 degrees Celsius. Right? Well, there's our ISA. Well, what ISA should be. Now, how far away from ISA are we deviating? And that's where we find our current temperature in the METAR. So now Salt Lake. Normally for the destination, we look at the TAF, but guess what? You're never going to find the temperature in the TAF. So we always just tell people, hey, go to the current METAR and just get that temperature. Some people some people think, okay, hold on, we're going to be landing in the future, so maybe the temperature is going to be a little bit different. Okay. If you want to change the temperature by 1 degree, then you'd be my guest. I just go with it. Again, if you want to do that, you're more than welcome to. I don't like to add more work to my plate. And so guess what? I'm just going to go with this most current METAR. I'm going to get that temperature of 13 degrees and I'm going to call it good. Okay. So 13 degrees Celsius is our current temperature. So Salt Lake, ISA is supposed to be 7. The current temperature is 13. So that's a difference of, what, 6 degrees? And from 7 to 13, we are getting warmer, right? We're getting warmer by 6 degrees Celsius. So ISA plus 6. Okay. You guys are going to get lots of practice with ISA and ISA deviations. So ISA plus 6, there is our deviation for Salt Lake. And I'll just put that right there. Okay. All right. Now, we found our ISA for departure and destination. We found our ISA deviations. Now we are going to jump into the IFR flight plan. We're going to start filling it out. Okay. This makes a lot more sense the more you do it. Okay. This is the part that tends to be the most overwhelming for people. And I totally understand why it was the most overwhelming part for me, because it deals with the most calculations. And it's really just kind of wrapping my head around TOC, which is top of climb, and TOD, which is top of descent. So once you can wrap your head around those 2 points and finding those 2 points, everything will start to make sense. Okay. But the more you do it, the more it makes sense. But with this process, follow these bullet points right here. This first bullet point with the IFR flight plan, now we are getting into performance numbers. Okay. Up until this point, it has all been estimates. We found our estimated time of arrival. We found our estimated fuel. We found our estimated takeoff weight. They've all been estimates so far. Well, guess what? Now we are going to go into the whole en route process as well. Now we're going to do performance. We're going to find the actual performance numbers for climb, for descent, and for the en route portion. We're going to do a lot of different calculations, and we are going to find our actual numbers. Okay. So with these flight planning steps with the IFR flight plan, just follow this to the T and you'll get it figured out. The first step is to fill out the climb portion from departure to top of climb. Okay. The second part is fill out descent portion from top of descent to destination. And the third part is filling out the cruise portion from top of climb to top of descent. It is going to take everything within you to remember that order. Because once you get to this part right here, your the natural way of doing things is to just go down the chart, right? To go down the table and start filling it out. But we are going to mix that up and say, okay, this is our climb portion right here. That is our first step. Our second step is actually the descent portion right here. And our last step is the cruise portion here in the middle. Okay, we're going to remind you over and over and over again, don't worry. And again, remember, I do not expect you to remember any of this tomorrow. I don't expect you to remember any of this on Monday. Okay, so we're going to remind you over and over and over again. Okay, fill out climb. This is the first step. Use the departure airport's ISA deviation. Remember, for Denver, we already figured it out. And that's going to determine what climb chart to use. We're going to use the performance number straight from the climb charts. And we are not going to factor winds on climb. Okay. When you are climbing up to 38,000 feet, your winds are going to change so much over all of those different flight levels. We're not going to make you go into all of those different details of the winds and correct for every single wind change over 38,000 feet, okay? We don't want to torture you that much. We're going to torture you a little bit, but just not that much, okay? So on climb, and you'll notice on descent as well, we do not factor winds, okay, for our class. All right, so coming back to this first bullet point, departure airport ISA deviation to determine what climb chart to use. So that ISA deviation for Denver was ISA plus 14. And on this IFR flight plan part, your ISA chart, you're going to put in right in this center section right here, the center column. ISA chart, you can put, again, two different ways of doing it, no matter, as long as you have your ISA deviation, you know which ISA chart you're going to use, okay? So ISA plus 14, right? Now, I like to put my actual ISA deviation in there. What you'll notice on Monday or even Tuesday when Jaden starts going over flight plan 2, he'll look at that and say, okay, that's your actual ISA deviation, but what chart are you going to use? When you look at your performance charts, let's go back up to the table of contents. And at the bottom of this page, here are all of your climb charts, here are all of your cruise charts, and here are all of the descent charts that we have available, okay? With climb, obviously -10, regular ISO or 0, right? +5, +10, +15, +20. Our ISO deviation is +14. So remember, we're going to go warmer, and we're going to go to ISA +15. So here's that climb chart. You can always double check yourself that you're on the right chart. So for climb, and then ISA +15 right here in the center. Okay. So this is where Jaden would put ISA +15 because that's the specific chart that we're going to use. I personally just put my ISA deviation in there. Either way works because just looking at it, I know that I'm going to use ISA +15. Okay. So you'll start to see different things that we all do. But ultimately, again, you get to the same answer.
Hey, Allison, quick question.
Yes.
If you're ISA +11, for example, you're going to go to 15. You're always going to go up for the next chart, warmer?
Correct. Correct. You always go warmer with ISA. Okay. So even if it was ISA -9, you would still come up to ISA. All right. Now, if you are ISA plus 25, just come down to ISA plus 20 because we do not have any more performance charts available for us, okay, to use. So I know that there is one flight plan where it's like you're going into a really hot city. Obviously, it's a summer a summer flight, and the ISA deviation is like ISA plus 29 or something like that, ISA plus 30. And you're just going to just use the ISA plus 20 chart because that's all we have available. Okay. I wish we had more ISA charts available to us, but we don't. Okay. Filling out the climb portion. We have let me go back to the climb chart. ISA plus 15 for climb. Here we go. All right. We are using the performance numbers straight from the climb charts. Okay, straight from the climb charts. So when we look at our IFR flight plan here, and we can start filling this out. So from Denver, right, we're going to go Denver to top of climb. And then our next box is our SID or our STAR or our jet route. Well, we are leaving Denver, so we're on a SID. And we are on the Rocky 7 departure. So right here, we're just going to put Rocky 7 right there. And we are climbing, right? Now we have all these other boxes in here. We have a true airspeed, a magnetic course, magnetic heading, ground speed, distance, time, and burn. Now we're getting into the meat of it, right? We're going to find actual numbers. Okay. True airspeed. This is going to come straight from our performance charts. So looking at these performance charts, again, this table right here, we have our side column for our flight level. And then up top, we have brake release weight. This is going to be our takeoff weight, okay, because we are climbing out of Denver. Our takeoff weight, remember, it was 64 and some change. And so we are going to go up to 66. And then our flight level is actually an even flight level, right? We're at 380. Well, we don't have a 380 over here. We have 37 and then 39. So we have two boxes to choose from right here. And I will zoom in so you can see it just a little bit better. So these two boxes right here. Well, with all this information, you have a legend up here. Okay. So the first number is time, as in minutes. We have distance. There's a Mach speed. We have our fuel burn, and we have our true airspeed, and then we have a rate of climb. Out of these 6 specific numbers, we only really need 4 of them. Okay, to fill out our climb portion. We're going to need time, distance, fuel, and true airspeed. Okay, don't worry about Mach or rate of climb. So with these 2 boxes right here, whenever you're at an even flight level, if you were doing the ADX or if the FAA came on, they would say, hey, you need to look at this, and what would they tell you to do?
Interpolate.
Interpolate, right? They're going to try and throw interpolation down your throat, and you're going to say absolutely not, because Alison said so. Okay. What we do, we keep it simple, right? Work smarter, not harder. Keep it simple and just look at the fuel burn. Go with the higher fuel burn. All right, we're going to lean on the side of caution. You're going up to 38,000 feet, which is in between these two. Just use the box with the higher fuel burn. The fuel is this top right corner. So to go to 37,000 feet is 2403. To go up to 39,000 feet is 2625. So that's the higher fuel burn. So just utilize this box right here. Keep it simple. Don't overthink it. Okay. Don't overthink it. I know some of you are just going to think, oh, I have to interpolate. I have to interpolate. Don't overthink it. So just, we're going to use this box and keep it simple. So this tells us all the information that we need for our climb portion. Okay. So we're going to start filling in this information. The first box is true airspeed. But when I come down here, remember true airspeed, this aircraft true airspeed right here, okay, in knots. It's this middle one over on the right side. It's 392. There is our true airspeed. Okay. Our magnetic course. Guess what? This actually comes from SkyVector. So on SkyVector, I'll zoom in here so you can actually see it a little bit better. In SkyVector, so far we have our route built. Well, to be able to figure out the course and the distances, we hit this little toggle button right here, and it's for showing the mini nav log. And when you click that, when you toggle it, now you can see all the information about the different points. Okay, so from Denver to Meeker, we're going to go at 162 degrees on the Rocky 7 departure. And from Denver to Meeker, it's 154.7 nautical miles. Don't ever worry about the time over here, because that is taking into consideration the current winds right now. And it's also thinking of a slower speed and a lower altitude. Okay, so don't worry about this time over here, because that is actually looking at current conditions right now. And we don't ever look at current conditions. We give you the conditions in your flight plan packet. All right. So what we need from here, we have 162 degrees. There's our course on this Rocky 7 departure. And it's going to go, it's going to take us 154.7 nautical miles to get to Meeker. So 162, there is our course. Now, then remember, we're not going to factor in winds for climb and descent. So when we get to the magnetic heading and ground speed for climb and for descent down here, you're just going to mirror these first two boxes right here. Okay, so the heading is the same as the course, and the ground speed is going to be the same as the true airspeed, because we are not factoring winds. Remember, I said we don't make you go into all the different winds going up to 38,000 feet. Okay, we don't torture you. So these two boxes over here, and this is just for climb and descent. We don't factor in winds. Okay, so they mirror each other right here. All right, distance, time, and burn. Guess what? Those are all on the performance chart that we were just looking at right here. Distance is right here in the middle on the left side. So 187.1. Time is right up above it. It's 28.6. And then your burn, that fuel burn, was 26.25. Okay. Now I'm going to just put this in there because we will need to get our new weight.
Hey, Allison, I think for the time you typed in 28.9. I think it's 28.6.
Oh, thank you very much. Oh, yep, I did. Thank you, thank you, thank you. Okay, I'm just going to find our new weight. I'm going to subtract that burn. Oh, wait. Okay, 26.25. Sorry, for some reason I was thinking 25.26. Okay, 61591. Right here. All right, so there's our climb portion. Okay, we got all those numbers. All these numbers were pretty much given straight to us, right? Most of them came from our climb chart right here. We just had to get the course from SkyVector. Now, this is where I say it's going to take everything in you to keep yourself from moving into the en route portion or the climb portion. But just stick with the process, trust the process, please. And just remember this, the first step is to do climb right here. The second step is to do descent. And then we can move into our cruise portion after that.
Hey, Allison, sorry. I understand you're getting the distance number 187.1 off of that form you were just on, but how do you derive that number? What's that coming from, 187.1?
This is the performance chart that we have from the manufacturer for this aircraft.
It's 187 miles from where to where, though?
From Denver, or from this specific, that we're looking at this. Remember, when we were picking our flight level, we utilized the ISA deviation specifically for Denver elevation, right? We got our flight level that we're capable of going to. And then with our specific takeoff weight, from all of the tests that they ran on this aircraft, they say at 66,000 pounds for a takeoff weight, going all the way up to 38,000 feet, it's going to take you 187.1 miles to do it.
Okay.
Okay.
Just out of curiosity, is that a literal number, or they were saying that's the equivalent of, at that weight and climbing to that altitude, that's the equivalent of 187.1 miles?
Yeah, 187.1 just straight from the ground up to top of climb. It's going to take 187.1 miles to do that.
And that's
Okay. You're saying that's the horizontal distance to get to 38,000 feet?
Yeah, so you're
Okay,
climbing,
understood.
okay?
Yeah, I got you now.
Great question. Because now,
That doesn't take into account wind though, right?
correct. So for climb and descent, we don't factor in winds. Don't factor in winds. Now, when you get hired at an airline, the computer is going to do all of this for you, okay? You're going to hate us by the end of class because we have to teach you how to do it manually, and you have to show how to do it manually for your practical. And then you get to an airline and you learn that the computer does all of this for you, okay? And the computer does look at the individual winds for all of those different flight levels, all right? We just don't torture you like that. We teach you the basic process of finding the climb numbers and doing performance for the cruise portion and finding the descent numbers. And we get those numbers, the climb and the descent, straight from the performance charts for the CRJ 700. Okay.
Miss Allison,
Yes.
are we able to use these notes that you guys give us in our practical? The checklist and stuff?
So like, are you talking about like all of these different things, all the different guides and everything?
Yes, ma'am.
By the time you get to your practical, you're going to have it memorized. You're not going to need it. Trust me on that. I know it's hard to trust me right now after seeing all this. I know it's hard to trust me right now, but
So that's a no, we're not allowed to.
You can't use any notes during your practical, but you will not need to use any notes anyway. Okay. So you can't use them. You can't bring in notes. You can take in blank paper and write down whatever you want to write down during your practical. They'll just keep it at the end of your practical. They'll take it from you. But I promise you guys, by the time you get to your practical, you will have this down. You'll know exactly where to look.
Memorizing these performance charts is going to be a real pain.
No, no, no. You don't have to memorize all these different numbers, okay? You will utilize your performance charts. Okay. You're going to utilize these performance charts during your practical. It's just all of these like guides to teach you how to do every single little step. You can't use these guides during your practical. But you will absolutely have your performance charts with you. Okay. All right. Let's do descent. Top of descent, we are coming into KSLC. Good old Salt Lake City. Now remember, SID or star, we are arriving into Salt Lake on the Spain 8 arrival. Spain 8. Okay, we already figured out our ISA deviation for Salt Lake. Our ISA deviation was ISA plus 6. So ISA plus 6 degrees. Now we are going to go to our descent charts. Okay, so let me zoom out of here. And coming back down, now we're going to be in descent right here. Well, for descent charts, the charts that we have available for us, okay, ISA minus 10, regular ISA, ISA plus 10, and ISA plus 20. Our ISA deviation is ISA plus 6. So we either use ISA or ISA plus 10. Which one are we going to use?
10.
Plus 10.
Why?
Warmer.
Yes. See, you guys are going to dream about it. You're going to hear my voice in your dreams. All right, so double check yourself. Descent chart, ISA plus 10. All right, well, we're at top of descent, which is 38,000 feet still, right? We haven't started to descend yet, but we don't have a weight, right? We haven't figured out our weight at top of descent right here. To do that, we really just say, okay, keep it simple, right? I'm all about keeping it simple. Remember this estimated landing weight that we figured out? All we say is give yourself a 500-pound buffer, and that is really just a weight to work with. Okay, so our estimated landing weight is 60,482. I'm going to add 500 pounds to that, and so that will give me 60,982. And that is just a weight to work with on here. Because, now I'm going to tell you the reason why 500 pounds, okay? If you look at these charts right here, again, remember the fuel number is in that top right corner. The highest fuel burn that you have, okay, going all the way up to 41,000 feet. Look at this highest fuel burn that you have. It's 489 pounds to descend. At all these other fuel numbers, you are never going to burn more than 500 pounds on descent. Okay? So that's why we just say, hey, give yourself a 500-pound buffer, and then it will help you have a starting point for a weight at initial descent, right? At top of descent. So that 500-pound buffer, it gets us to 60,982. We're heavier than 60,000, so we'll go to 62. And then again, we're at an even flight level. So with these two boxes, just look at the fuel burn and go with the higher fuel burn. So remember, fuel is in this top right corner. So for for this box, we have 387, and for this box, we have 318. So we'll go with the higher fuel burn, and there is our box of information that we need. Again, we'll use the time, the distance, the fuel, and the true airspeed. All right? You don't worry about the rate of descent or the Mach. So this first, not right here, up here. This first column right here is that true airspeed. So our true airspeed is, remember that ATAS, that knots, 388. So 388 right here. Our course comes from SkyVector. Now remember, we're going from top of descent into Salt Lake. Okay, so we're going towards Salt Lake now. Oh, SkyVector, sorry. And there we go. Now we are going towards Salt Lake. Okay, we are on the Spain 8 arrival. So going towards Salt Lake, we are going to be at 264 degrees right here. Okay, so 264. Again, we do not correct for winds on descent, okay, on climb or descent. So these next two boxes are going to mirror these boxes again. So our heading and then our ground speed. Distance, time, and burn. Remember, they all come from the performance chart. So that 62 and then that 390. So our distance, okay, our distance is 111.9. Our time is 17.3. And our burn was that 387. Okay, so there is descent right there. All right. Now, we just filled out climb and we just filled out descent. The next portion is our cruise portion. So this is where we are going to start when we come back from dinner, because you guys need a break. All right. You guys, I've thrown a lot of stuff at you, so let's do 20 minutes, okay? You good with that? All right. You know what? Let's do 23 minutes. Come back at 50 after the hour. Okay. Let's finish this thing. Okay. What we just did when we started our IFR flight plan, we did our climb section, we did our descent section, and we got pretty much all these numbers right from the performance charts, right? We love the climb and descent charts because it pretty much gives us everything we need. We don't have to do any calculation. We don't have to do anything, right? We just fill in the boxes. Well, now we are going to do our cruise portion or our en route portion. And to be able to do that, we are going to draw a little bit, right? We don't want you to only focus on these numbers. We want you to get in touch with your artistic side. And so you're going to see my artistic side on the computer, which is not that great. But what I do personally, I just needed some space. So I'm just going to come to the very end of this. This is during the cruise portion. This is where you will be utilizing this page. So flight plan leg calculations. Okay. So what I'm going to do, I'm going to draw my own, pretty much it's a lifespan of a flight, right? You go from your origin to top of climb, and then you cruise all the way to your top of descent, and then you descend into your destination. And so I call it I call it the lifespan of my flight. It's just the flight plan leg calculations. That's all it is. Okay. So this really, it looks messy with all of these different numbers on here, but when you actually get into it and start figuring out all the different numbers, it makes a lot more sense. Denver to Salt Lake is such a short flight that when we actually go in and figure out where top of climb and top of descent are for Denver to Salt Lake, you're going to notice that there are some numbers that we don't even have to worry about because it's such a short flight. Okay. But with this page, it tells you exactly what the number means. So this number 1 over here on this left side, this is the distance from the climb chart, right? So from the origin to the top of climb, that is number 1. And number 2 is distance from, not the descent chart, it's a descent chart. So top of descent into our destination airport, that is number 2. And then number 3 is that total length or total distance from SkyVector. So from origin to destination, that is your total distance from SkyVector. And then we're going to start getting into everything else, okay? Number 4 is top of climb to top of descent. That is your whole cruise. And then 5, we're just going to get into it. 5, I'll explain it as we go along, okay? But I'm going to go back to my dispatch release and I'm going to draw my own for Denver to Salt Lake. Okay. I got my climb. I got my cruise. And I got my descent here. All right, this is Denver. And this over here is Salt Lake. This right up here is top of climb. And this over here is top of descent. Okay. Now, with my climb, guess what? I already have that distance. Remember, I came into my performance charts and I already got that distance right here. So Denver to top of climb is 187.1. Well, you know what I can do? I'm just going to move it around. There you go. Okay, distance 187.1. So I'm going to come back down here And I'm going to put my distance, 187.1 from Denver to top of climb, right? Top of climb is at 38,000 feet. It's going to take me 187.1 miles to do that. We get all the way up to 38,000 feet. Now, top of descent into Salt Lake, performance charts gave me that distance as well. So my descent chart, that distance, 111.9. So from top of descent into Salt Lake, descending from 38,000 feet, getting into Salt Lake, it's going to take me 111.9 miles, right? Now that number 3, remember Denver to Salt Lake, that was the total distance coming from here, 372.4. That is according to the route that we built for it. Remember that this is the actual distance that we're going to go with our SID and our star and our transition point in there. 372.4. So that is from Denver to Salt Lake. 372.4. And maybe I'll do an arrow. Whoa, never mind. I do not want to do an arrow. Shoot. Just put it on there. Whatever. Okay. So 372.4 is the total distance from Denver to Salt Lake. Okay. Well, top of climb to top of descent. Now we get to figure that out. So guess what? A plus B equals C, right? So now just keep it a simple equation for yourself. I have Denver to top of climb is 187.1. Top of descent to Salt Lake is 111.9. And then I have this solve for X right here, right? Well, my total is 372.4. So let me just do some basic subtraction here. Oops. Okay, my total. I'm just going to subtract the climb and the descent. There you go. There's my top of climb to top of descent. That total right there. So 73.4. Okay. Top of climb to top of descent. We are going to be at cruise for 73, almost 73 and a half miles. Okay. Very short flight from Denver to Salt Lake. And we're climbing all the way up to 38,000 feet. If we roll, oh, go ahead.
Because I don't know if you did 187.1.
Oh, over here?
Yeah, you put 185.3.
Okay, so I took 372.4, which is the total.
Yeah.
And I subtracted 187.1, which is the climb.
Mhm.
And then just subtracted that descent of that 111.9.
Oh, I bet.
And that gives us 73.4. It's just because I hit enter.
Yeah, no. Okay, yeah, never mind.
Okay, are we good? So 187.1 plus 73.4 plus 111.9 equals 372.4. All right. Okay, top of climb to top of descent, it is 73.4 miles. Now, when you go back to the flight plan steps for this cruise portion, the first bullet point says, break the route up into approximately 250 mile segments, okay? And reference this flight plan leg calculations guide that we've been looking at right here. When it says break it up into approximately 250 mile segments, well, this is only for cruise, but if we look at our cruise is only 73.4 because it's such a short flight, right? It is a short, it's not a far distance from Denver to Salt Lake. Now, if we were doing a lot longer flight, let's say, let me zoom out here and we'll just let's say we were going from Seattle all the way down to LA. Okay. Seattle to LA. Well, that's a lot further distance, right? You're going a lot further to go from Seattle to LA. And so in that case, that's where we say, hey, because you're going such a long distance, during your cruise portion, kind of chunk that up into smaller pieces. Okay. This one, we don't need to do anything because it's such a small distance of 73.4 miles. We don't need to chunk it up into smaller pieces. Okay. We really just say, hey, keep those segments, those longer flights, keep those cruise segments to 250 miles because the winds and the weather can change a lot, right? So one of your flight plans, I'll just give you an example. And you know what? I'll just put it in really quick, just so you can have a direct line. Okay, I'll just show you. So one of your flight plans goes from Oklahoma City to LA. This distance right here, this direct distance is 1,031.5 miles. That's a pretty far distance, right? You're going, I mean, just looking at the country, you're going like almost half the country from OKC to LA. Well, your weather and your winds, it's going to change a lot as you fly west towards LA, right? I mean, those of you who are from Utah, think of the weather in Salt Lake versus the weather in St. George. It is drastically different. In Salt Lake, they are under snow, and here in St. George, I mean, currently it's raining, but normally, 360 days out of the year, it is beautiful and sunny. Whereas in Salt Lake, they get snow and crappy weather up there, okay? And from St. George to Salt Lake, it's what, roughly, I don't even know, 400 miles, I'm guessing. Is it about 400 miles? That weather changes so much over that distance. Even just St. George, from St. George to Cedar City, the weather can be complete opposite, okay? And that's just about 45 miles. So what we do is we just say, hey, on your longer routes, during your cruise portion, wherever you hit top of climb and top of descent during your cruise portion, just kind of chunk that up a little bit smaller, because then we're going to do performance numbers for those segments in here, and we're going to get a lot more accurate performance numbers as far as your fuel burn and your time. Okay, so that's what this is referring to when it says break route up into approximately 250 mile segments. We're not going to see this specific thing on this route, on this flight plan, because it's just Denver to Salt Lake, but you will see this on your next flight plan. Okay, your flight plan 2 is a longer route, and so you will see us break up the cruise portion into smaller segments. Okay. Okay, the second bullet point. Determine ISA for the segment of route. Now we are in cruise, so guess what? We have winds aloft at that specific flight level at 38,000 feet. So we are going to correct for those winds aloft. So use winds aloft from the location closest to the route segment, and then use the flight level of the winds aloft from the ISA calculation and not your planned flight level. I know none of this really makes any sense to anyone, and I'm just going to walk you through it, okay? So first of all, we need to find ISA for our segment of route. Well, our segment of route that we just figured out is top of climb to top of descent. It's just 73 miles. We don't need to break that up into smaller pieces because it's only 73 miles, okay? So 73.4, there is our cruise segment right there. We're only going to be at cruise for 73.4 miles. So up here, our next line right here, we're going to start at top of climb, okay? So TOC, but now, oops, sorry, can't type. We are going all the way to top of descent, TOD. We don't need to add, we're not breaking up cruise at all, the cruise segments. We're not making anything smaller. We're not adding any points. We don't even have a jet route in there, right? Because Meeker is our transition point. So we don't even need a jet route in there. So at top of climb to top of descent, this is SID or star, right? This is where we have to figure out, okay, where's top of climb and where's top of descent? We already figured out the distance, and that's the, what was it, 73.4? Yep, 73.4. Oh, I went too far, sorry. So we already know the distance, but now we have to figure out if we are still on our SID or if we are already on our star, right? To figure that out, we're going to come back to our drawing. And in our drawing, remember, we got our climb number from our performance chart, and we got our descent number from our performance chart. Well, does this tell us where exactly Meeker is? No, it doesn't. We have to figure out where top of climb and top of descent are in reference to Meeker. So let me put in the route again really quick. I think it was the Rocky 6. Yep. So in this little mini nav log, right, remember the toggle? It gives you the distances, but this is according to your actual filed route that you built. This doesn't tell you where top of climb and top of descent are, right? We don't see a TOC or TOD in there. So we have to figure out where top of climb and top of descent are with, in reference to our route. Okay. This just tells us plainly, okay, from Denver to Meeker, it is 154.7. Well, when we look at our timeline, pretty much, of our flight right here, Denver to top of climb is 187.1. So that means we are already past Meeker and we are still climbing, right? Because Denver to Meeker, I'll just draw another line right here. And we'll just put Meeker, EKR, right? Denver to Meeker is that, what was it, 150 something? 154.7. Okay, so this is the SID. Denver to Meeker is that SID, and it takes 154.7 miles to get to Meeker. Well, that means we're still climbing for another 30 something miles until we hit 38,000 feet. Okay, so now think, okay, after Meeker, what am I doing as far as my route? Well, guess what? After Meeker, now we're on the Spain 8 arrival. Okay, so after Meeker, oh, I don't have my line. After Meeker, all the way over to Salt Lake, we are now on the arrival. So that's what's funny about getting all the way up to 38,000 feet on such a short flight, is that we are on our arrival and we are still climbing. Okay. So we just have to figure out, okay, when we hit cruise, right, top of climb right here, are we still on our SID or are we already on our star? And so that's why we had to figure out, okay, where's Meeker in reference to top of climb? Meeker is before top of climb. So we pass Meeker, and after we pass Meeker, now we're on our arrival into Salt Lake. And our arrival into Salt Lake is the Spain 8 arrival. So over here, we are already on our Spain 8 arrival during cruise. Okay. Sometimes that can be kind of hard to wrap your mind around just because this is such a short flight and we are capable of going so high. Okay. But we just had to figure out, okay, where's Meeker in reference to top of climb? I just had to figure out where's my top of climb. I already have the distance for it, but I just had to figure out where top of climb is in reference to my filed route.
Is it going to change your point-to-point distances in SkyVector if you change the altitude on there? Because isn't it basing those distances off of a cruise at 8,000 feet that was on there by default?
So this is just, I mean, you can change it to even if you do 340. Okay, it doesn't change the distance. The distance is the distance.
Okay. It just
Okay.
seemed like it should be farther. I mean, if you're flying at 38,000 or 34,000 feet, climbing up to that and then climbing back down or cruising back down, that it would be a farther distance from point A to point B versus if you were to fly 500 feet off the ground the whole way. So.
Yeah, it's just the total distance from Denver to Salt Lake. And according to our performance, right, according to our takeoff weight and the ISA deviation, that's where we get our performance numbers for the aircraft to go all the way up to 38,000 feet. And then we're just cruising for 73 miles and descending into Salt Lake, and that's going to take 111, almost 112 miles.
I think his probably to his point, he's probably thinking that you would never actually in real life plan to go all the way to 380 for this short flight because it would be less efficient than at a lower altitude.
Correct. Yes, correct. But the distance is still the distance.
Right. It's horizontal miles traveled over the ground
Yes.
to get to your top of climb. So it has nothing to do with actual
Yep. Yeah, in reality, me personally, I'd probably file this at about 30,000 feet. But for this class and to keep it simple, we just say, hey, go to the highest flight level that you are capable of getting to. Okay. So short flight, here's our SID from Denver to Meeker, and we are still climbing. And we are already on our star. We're already on our arrival. We're still climbing for another 30 miles. We hit top of climb. We cruise for 73 miles, 73.4 miles. We hit top of descent, and then we start to descend into Salt Lake. Okay. All right. Now, that was right here. We figured out that we are already on our arrival during our cruise portion, our top of climb to top of descent. Our flight level, we're at cruise, right? So at 380. Well, guess what? Now we get to fill in all of these other fun things, but now we are at 38,000 feet. We're cruising at one flight level. We're not climbing or descending. So now we have these winds aloft that we have to correct for. So true airspeed. True airspeed comes from the performance chart, but we need to figure out our ISA deviation for this portion of the route. And we haven't figured that out yet. So we don't know which chart to look at for cruise. So let's do ISA, because I know you guys love it. All right, back to the beginning for ISA. Okay, first of all, we're going to find ISA, and then we're going to find our ISA deviation, right? Okay, for ISA, we're not at an airport anymore. We are at a flight level. So we're going to use the flight level from the closest flight level at our winds and temps aloft. Winds and temps aloft, they are going to be on your flight plan at the very end. So flight plan, very end. Here's your winds and temps aloft. Now, what we do, you have your different altitudes here, right? Your flight level, our flight level is 38,000 feet. Well, we have a column for 34,000 feet and a column for 39,000 feet. Again, if, you know, if you were doing the ADX, it would say, hey, you need to interpolate. And that's where you say, Alison says, no, I don't have to. And we say, keep it easy, keep it simple. Just go to your nearest, your closest flight level on your winds and temps aloft right here. Okay. So we're at 38,000. We're going to use this 39,000 column. That's going to be our closest winds, our most accurate winds and temps aloft. Okay. All right. So this 39,000 column, what we do for our flight plans that we have for you, we give you these weather centers along your route. Okay. We don't give you any surprises or anything like that. We just give you different weather centers that are located along your route, and you get to choose which weather center makes the most sense for your portion, your segment that you are getting winds and temps aloft for. Okay. So what we're doing is we are doing top of climb to top of descent, right? We correct for those winds aloft, top of climb to top of descent. Well, what we just figured out, Meeker's right here in the middle, right? We already figured out that, guess what? We hit Meeker and we are still climbing 30 miles past it. And that's where we hit top of climb, right? That's where we start cruising. And we cruise for about 73 miles. And then we start descending into Salt Lake. Okay. So this portion of the route right here, this is where we are going to try and find the closest winds and temps aloft for that portion. All right. On your flight plan right here, this first weather center is Denver. Well, guess what? We're already way past Denver, right? We've already departed Denver. Denver doesn't make the most sense for winds and temps aloft at, you know, right here in 39,000 feet. This next one is MBW, or Medicine Bow. So let's go find out where Medicine Bow is and see if that's the closest weather center to our cruise portion. And after that, we can look and see where RKS, or Rock Springs, is. And just, we're going to pick the one that makes the most sense. Okay. Pick the closest one to that portion of the route. So MBW, remember this search bar over here in the top left corner. And this tiny little plus sign right here, it's going to center on Medicine Bow. All right, Medicine Bow is right here. I can't even see the pink line, right? When I zoom out just a little bit, there's my route. Medicine Bow is all the way over here. Well, that's not even close to my cruise portion over here. So now I'm going to find where Rock Springs is. Rock Springs is right here. Guess what? That makes a lot more sense to my cruise portion. It's going to give me a lot more accurate information. So Rock Springs is what I'm going to use. This 39,000 feet over here, those are my winds and temps aloft. Let me see if I can just copy it. So remember, winds and temps aloft, the first two digits are the wind direction. The middle two digits are the wind speed. And the last two digits are the temperature. And remember, at 39,000 feet, we are in the negatives. So 64 is negative 64 degrees Celsius. Okay, so winds from 220 at 65 knots, and it's negative 64 degrees. I'm copying this because in here, I am just going to, come on. I'm just going to paste it, because eventually I'm going to correct for these winds aloft right here. Okay. Now I need to figure out ISA and ISA deviation. Okay. I just figured out where my winds and temps aloft are for this specific segment. And now I need to do ISA and ISA deviation for it. So ISA, all right, the flight level closest to your winds and temps aloft. So we're using the 39,000 column, right? We don't need to round it because it's already an even number, 39,000. We're going to take that and we're going to move it 3 decimal places. So 39,000 becomes 39, right? Here, I'll put 39,000 and do 39. Okay, we're going to take that value, multiply it by 2. It's the same process, right? I'm not even going to try to do that in my head. 39 times 2, 78. Okay, now we are going to take 78 and we're going to subtract that from 15. So 15 minus 78, negative 63. So that is what ISA should be at 39,000 feet, negative 63 degrees Celsius. Okay. Well, now to find our deviation, we just need to go find our current temperature in our winds and temps aloft. Okay. Winds and temps aloft. So our current temperature is negative 64. Well, from negative 63 to negative 64, it's a difference of 1 degree, right? But from negative 63 to negative 64, are we getting warmer or are we getting colder? From negative 63 to negative 64.
Colder.
Yes, we are getting colder. So instead of a plus sign, it's going to be a minus sign. ISA, which is negative 63, right? ISA minus 1 degree Celsius equals that negative 64 right there. So there's our deviation. We're deviating away from ISA by 1 degree colder. Okay? Remember, when you get into the cruise portion, you are going to be up at a very high altitude with negative numbers, and it is going to take you back to elementary school with your number line. And guess what? Sometimes those negative numbers get people. So just think, okay, am I moving closer to 0 or am I moving further away from 0? All right? Those negative numbers, they get people. But now we have our ISA deviation. So guess what? Now we know which ISA chart we are going to use. Our deviation is ISA minus 1. Let's go to our cruise charts now. We have ISA minus 10 and ISA. Which one are we going to use and why? Our deviation is ISA minus 1.
ISA, because you want to go warmer.
There you go. So cruise and regular ISA right here. Cruise and ISA. All right. So guess what? We have our cruise chart that we're going to use. Okay. We are at an even flight level, so we're going to be in between 3.7 and 3.9. And now we need our new weight, our aircraft weight. So our new aircraft weight over here is 61,591 pounds. We are heavier than 60,000. So we are going to go to 62. And now these charts, the cruise charts, the information in here looks just a little bit different. If you look at the legend over here, from the cruise charts, we really only need 2 pieces of information. Okay. We need our pounds per hour per engine. That's going to be our fuel burn. Pounds per hour per engine. And then we need our knots, our true airspeed. Okay, not the indicated airspeed. Don't look at the KIAS. Always go for the KTAS, the true airspeed. Okay, so we just need these 2 pieces of information from our box. So 62,000. And now we have these 2 boxes to look at. So when we are having to choose between 2 boxes, we're not going to interpolate because Alison said no. we are going to go for the higher fuel burn, right? So this fuel burn right here says 1438, and this one right here says 1492. So 1492 is going to be the higher fuel. So we are going to utilize this box right here. Okay. All right. Let's keep working along. Okay, our true airspeed comes right from that performance chart. Remember, true airspeed is now in this bottom right corner for cruise. So our true airspeed right here says 441. Our course, we get our course from SkyVector. And guess what? We are already past Meeker. And so our course is just going to be that 264. We're still heading straight, pretty much due west over towards Salt Lake. So 264, okay? But now, guess what? At 38,000 feet, cruising along, and we have these winds aloft that we have to correct for. So we are going to use what is called the E6B calculator. And some of you might already have an actual E6B calculator. If you want to bring it with you, you're more than welcome to, but you are able to utilize the E6B calculator website during your practical. So I highly recommend just utilizing the E6B calculator on the website, and just go to Google, just do E6B, okay, E6B calculator, and it's just this first one right here, E6BX, okay, this calculator right here. Oh, and I am super zoomed in, sorry. Okay, I'll zoom in just a little bit. So this is the E6B calculator. Again, you can use this website for your practical, and I highly recommend just using this website. It's very user friendly, it's very nice, and you really just need to use this first section right here. And then what's nice is, you know me, I'm a visual learner, and so it gives you this illustration over here on this right side. I love it because then I can actually see what's happening with my winds aloft. Okay. So what we need to do, we're going to come in here, we're going to change our course. We're going to add in all of these different numbers that we have according to our flight plan right here. Okay. So our course that we have is 264. So we're going to put in 264 right here. Our true airspeed, remember that came from the performance chart. Our true airspeed is that 441. Now we need to change our wind direction and our wind speed, and that's exactly why I put the winds and temps aloft right here, just so I don't have to keep going back to the flight plan, right? So winds aloft, we have they're coming from 220 at 65 knots. So wind direction is 220. And the wind speed is 65 knots. Now, it gives you that wind correction angle, which is just great information to have, but it gives you your heading and your ground speed. So it corrects for these winds aloft, and it spits these numbers back out at you for your IFR flight plan. So our new heading, correcting for those winds, our new heading is 258. And our ground speed is now 392. Oops, sorry. Okay. So we don't mirror these during cruise because we correct for these winds aloft. And again, it shows you, it doesn't, dang it, it doesn't do the illustration bigger. When you actually look at this on the website, it shows you the different arrows, okay, for your specific course. And it's saying, okay, you are going on this course right here, but you have winds coming from this direction. Because you have winds coming from this direction, to continue on straight, right? We want to continue on straight towards Salt Lake. You have to correct that. So now you have to put your heading in a little bit into the wind to keep moving forward on your specific course. Okay. So I love this illustration because it actually shows you how it's correcting for those winds. All right. But on this website, these top 4 boxes right here, that's what you're going to change. And then it gives you your updated heading and your updated ground speed. Okay, and we just put those right there for magnetic heading and ground speed right there. All right. Now we get into our time and our burn. Okay. Now we remember when we figured out time, right? Time equals distance over rate. Remember that calculation, that equation that we have? Well, guess what? We have distance and we have our rate. So we are going to take our distance of 73.4. We are going to divide it by 392, which is our ground speed. Now this is going to give us our decimal, remember? Gives us a decimal, so we are going to multiply that by 60 because we're going to change it to minutes. We're going to change it over to minutes. Multiply that by 60. 11.2346938 blah 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 minutes. So this is where I just go out to one place over for time. Some people just round it. That's up to you. I like to go one place over from the decimal just because it gives me a little bit more accurate time. So 11.2 minutes. I don't round to whole numbers when it comes to time. Okay. I absolutely round to the next whole number with fuel. So now we are going to find how much fuel are we going to burn to go 73.4 miles at this speed, right? It's going to take us 11.2 minutes, but now how much fuel are we going to burn? Now, going back to the performance charts, we know this is our pounds per hour per engine. This doesn't just give us a total fuel burn because this is per hour for one engine. Okay, so 1492, that is a full hour for one engine. Well, we have 2 engines, right? So we're going to take that 1492 and multiply that by 2. And that is 2 engines for an entire hour. Well, we're only flying 11.2 minutes, right? So take this, we're going to divide by 60. That gives us a burn per minute for these 2 engines. And then multiply that by how many minutes we're flying. 557.133333. So me personally, I will do 558 for the fuel burn. To go 73.4 miles. It's going to burn 558 pounds. Okay. All right, I'm going to subtract that 558 and get an updated weight. $61033. Okay. Well, we don't have any other cruise lines because we are going from top of climb to top of descent. And then our descent, we go top of descent into Salt Lake. So guess what? That is our only performance line that we have to do during cruise. So let's bring all of these numbers down, this weight down here. So 61,033, just double checking myself. We are going to subtract this descent burn now. Okay, so 387, 60646. There is our landing weight, okay, our estimated landing weight. Now, what we're going to do is we're going to total up these columns right here. So our total for our distance, this should equal what we have in SkyVector. right? Because the distance is just that that same distance. 372.4, which it does. Hey, does anyone remember that padded distance that we figured out at the very, very, very beginning? Remember we took our direct distance and multiplied it by 1.1? Does anyone remember that padded distance? I'll remind you. So remember we got that direct distance, we rounded it to just 340. And then we padded it by 10%, and it was 374. Guess what? Our actual distance is 372.4. Pretty darn close. We're just doing estimates. Okay, our time, 28.6 plus 11.2 plus 17.3. 57.1. Who remembers our estimated time en route that we estimated at the beginning?
Seems like it was 56 something.
Yep, it was 56 minutes. 56.1 minutes. So we are actually 57 minutes. So why do you think it's actually taking us 1 minute longer?
Winds.
Yep. We have these winds coming from 220. We're trying to go 264, right? 264 as far as our course. Well, we have kind of pretty much mostly a headwind coming at us. And so it slows us down by 1 minute. And that means, guess what? We have a new ETA, our new time of arrival. We'll get to that. Let me just do this total fuel burn. 3570. All right, remember we did our estimates for our fuel burn. Our estimate was 3734. Our fuel burn, our actual fuel burn is 3570. So this is why we do our performance numbers, because we get more accurate time and more accurate fuel burn. Right? Real life dispatching, you do estimates first, and then the computer looks at it and it considers these en route winds, all the different changes en route, right? And it spits back the actual fuel and the actual time. So your ETA updates after the computer computes everything. Okay, real life dispatching right there. Okay, how you doing? Do you need a break? Yeah? Okay, let's do 10 minutes. Come back 48, and then we'll finish everything up, okay?
Miss Allison,
Yes.
sorry to bother you. I have a CX-3 calculator. Is it equivalent to EXB?
I don't know, honestly, I don't know. I highly recommend just utilizing this website. And once you use the website a couple of times, you will get it. You'll know exactly what to do.
Uh-huh. I
Okay.
see. Thank you.
Uh-huh. Okay, let me know when you guys get back. All right, we have about 45 minutes. We are going to finish this up. We have already gone through the most complicated parts, okay? Everything now is really just filling in boxes with information that we have already figured out. Okay, so we just finished our IFR flight plan for the most part. Now we just figure out all of we put in our actual numbers down here. But this is what, this is technically, this tends to be the most difficult part for people to figure out. But honestly, the calculations don't ever change. Once you get the calculations down and you start to remember where all of these bits of information come from, you guys are going to be totally fine. Okay. And you'll get there. I promise you will get there. Okay. So we just figured out our actual burn. We just figured out our actual time. Our distance is our distance, right? But now we are going to figure out our actual takeoff weight and our actual landing weight. Because even up until this point, for the aircraft weight, that came from an estimated takeoff weight, right? And even this would be technically an estimated landing weight. So now we're going to figure out our actual landing weight, putting in all of these more accurate numbers with the fuel burn and the fuel burn for this flight from Denver to Salt Lake. So this fuel burn, this 3570, I'll zoom into these smaller boxes over here just because they are tiny. We're going to put in our actual numbers over here. Okay, so 3570 for our burn. Our reserve is always the same. We didn't have an alternate, right? We don't have any extra hold fuel or contingency fuel. You'll hear a lot of different terms for that extra fuel. And for the most part, it's hold fuel or contingency fuel. But we don't have any extra fuel on board. So we're going to add that together. And now we are going to get our actual Minto. So our actual minimum fuel for takeoff is 6,070 pounds. Okay. We're going to add in our taxi fuel of 250. And this gives us our ramp fuel, okay, or our block fuel, 6320. Now you see these arrows here. We're going to follow the arrows because we are good students. So our takeoff fuel, our minimum fuel for takeoff, is that 6070 right here. And our actual burn over here is this 3570. Now all of these other numbers, we've already found them. Remember when we did our weight and balance. So we're just I'm gonna make it easier on myself, and I'm gonna shift my there we go. This will make it just easier for us to refer back to. Okay, our bow, 44848. Our payload, remember what payload is made up of? It's our passengers and our cargo. So 11184 plus our 1950. So our payload is 13134. Now, when you add those two together, it should equal out to your zero fuel weight, 57982, which it does. All right, now we are going to add our actual Minto. That's 6070. So our actual takeoff weight is 64,052. Okay. It's our actual takeoff weight. And then we are going to subtract our actual burn of that 3570, and this is going to give us our actual landing weight. 6482. That number sounds oddly familiar. And guess what? It happens to be our estimated landing weight. Those should match, by the way. When all is said and done, those should match. Okay. So we figured out our actual fuel burn. We figured out our actual takeoff weight and our actual landing weight. Now everything else on our flight release, our dispatch release, we are just it's just filling in boxes now. So guess what? This is all the easy stuff. Okay, our date. I don't even remember our flight plan date. March 14th? Yep. March 14th, 2018. March 14th, 2018. Captain. Obvious in all caps. Dispatcher, the class, because we did it all together. This is the original release. It's not an amendment. We're not changing the original release. We always file IFR. Okay. Our flight number, this is flight plan 1. Our tail number, you see how we're just repeating ourselves over and over. We're going from Denver to Salt Lake. We don't have any alternates, right? Our flight level is 30. And we're going to just keep going on. All right, our estimated time of departure was at 2025 Zulu. Now our estimated time en route has changed by 1 minute, right? It's 57 minutes en route, not 56. So now our ETA changes. Remember, originally it was 2121 Zulu. Well, guess what? That means it's 2122 Zulu by 1 minute. Now, our knots true airspeed. When you're looking for your knots true airspeed, that is only during cruise, okay? Your cruise portion, your true airspeed. Normally on the longer flights, you're gonna have multiple segments here, and it's really just finding the average true airspeed, okay? We are just going from top of climb straight to top of descent on this flight plan, so our true airspeed is 441. Nice and simple. Okay, now we are going to put in our actual numbers here. Okay, our en route fuel burn, our actual fuel burn was that 3570. We still don't need an alternate because guess what? When we look at our TAF and look at our updated ETA, it is now 2122 Zulu, right? Oh, come on. There you go, 2122 Zulu. We are still in the same line. We still have greater than 6 statute miles. We still have the same ceiling. And we still don't require an alternate. Okay, always double check your weather. With your new ETA, always double check your weather to see if you now require an alternate or not. We still don't require an alternate, so we don't need any additional fuel for an alternate. The reserve is always 2,500. And so when you add your actual fuel burn with your reserve, we got that 6070, right? The 6,070 pounds. We don't have any extra fuel. Our taxi fuel is always 250. And that means our ramp fuel is 6320. Okay. Remember, on this first page, we use our actual numbers that we just figured out on our IFR flight plan, okay? Because why do all of that work and then just put the estimate numbers here and give it to the captain? And the captain's going to look at it and say, hogwash, give me the actual stuff. So why go through all the pain and suffering and work of the IFR flight plan when we, would just try and give them estimates? They don't want estimates. They want the actual numbers. Okay, the performance numbers. That's what they want. All right. Okay, Denver, 16 right. Our planned temperature for Denver. What was it? 18 degrees? Yep, 18 degrees Celsius right here, that most current METAR. Planned wind. Well, from our METAR, variable at 3 knots. Now, if you happen to put the 120 at 11 knots, that's totally fine too, right? We were looking at those forecast winds to pick our runway. Either one will work with your planned winds. I don't care. No one else is going to care because we aren't going to look at that, right? That's not going to affect anything as far as filling this out. Okay, plan max runway takeoff weight. What is your max takeoff weight for the CRJ 700? Your max takeoff weight.
75,000.
Thank you. All right, and flap setting for takeoff. It's always going to be 8. Okay, takeoff flap setting is always just going to be 8. All right, now your planned takeoff weight that we just figured out. Our actual planned takeoff weight, 64,052. All right, our max V1, I'm going to hold off on that because we are going to get more V numbers, our V speeds. Okay, I'm going to hold off on that. All right, Salt Lake, 16 left. Our planned temperature for Salt Lake, I think it was 13. Yep, 13 degrees Celsius right here in this most current METAR. Planned wind. Now you can get that right from the TAF for planned wind, 170 at 10. All right, planned max runway landing weight. Max runway landing weight. Numbers, that's 67,000. Flap setting, we always do 45. Okay, always just do 45. Planned landing weight now. The landing weight that we just figured out, it's actually planned to be 6482, which is what we estimated in the first place. All right, any MELs? None. If you had any MELs, you could just put the MEL number. And if you wanted to, you could just kind of put any restrictions that go along with it. You could also include that in your remarks. Any remarks, this is the last chance that you have to explain why you planned what you planned, right? How you planned it. We didn't have anything kind of off the wall with this flight plan, so we're just going to say, have a nice flight. Right? So there's the first part of the dispatch release. We have one more page. I think one more page. Yeah, one more page to fill out, and then guess what? We are going to be finished with Flight Plan 1. The CRJ 700 performance worksheet right here. Again, guess what? We are just repeating ourselves over and over and over. Oops. And when you look at an actual dispatch release, you're going to see the same thing. You're going to see the date everywhere. You're going to see the flight number everywhere. You're going to see the departure and destination, every airport, right? All possible airports that you're going to use. They're going to be everywhere on your dispatch release. You're going to see the captain's name. You're going to see the dispatcher's name. You're going to see all of these performance numbers on your dispatch release. So, departure, Denver. Destination, Salt Lake. Captain, obvious. Paired by class. All right, now we're going to go into the different weights and more specific, just more details about the runways and stuff. Departure airport, again, Denver. 16 right. Flap setting 8. Outside air temperature was that 18 degrees Celsius. Runway allowable takeoff weight. We don't remember, we don't make you go into the spaghetti charts to like figure out your actual takeoff weight with, you know, all these little different things included. This is just going to be your max takeoff weight. Okay, so 75,000. This next line is for takeoff alternate airport. We don't have a takeoff alternate, so guess what? We don't need to fill this out. This third line, destination, Salt Lake, 16 left, flap setting 45, outside air temperature 13, max runway landing weight, right, 67,000. Destination alternate, we don't have a destination alternate. Now we're going to go into the simplified flight planning. And on this top line, it's going to be in pounds. Okay, this is really just fuel. So pounds up top, and then this bottom line is going to be in time. So our burn to our destination was that, what, 3570? I'm going to double check because I don't. 3570. Okay, cool. Now our reserve is that 2,500 pounds, right? We didn't need an alternate. So here's, you'll see contingency right here. It's just the same as hold fuel. We don't have any extra fuel. So our takeoff fuel is that 6070. And then adding that 250 was that 6320 for our release fuel or our ramp fuel, or AKA our block fuel. You'll hear all of these different terms, okay? And they're pretty much all the same thing. Okay, our burn to our destination. Right here it's in pounds, but now our burn as in time. So our time to destination was that 57 minutes. Our reserve fuel, how many minutes is 2,500 pounds? Remember our reserve amount? How many minutes is that?
$45.
Very good. Yep. You guys have noticed that I'm a patient person. I'll just wait for you to respond. All right, no alternate. Again, no contingency fuel. All right, now our time with fuel, right? So we're going to add 57 and 45. I'm not even going to think about that. I'm just going to the time calculator. So 57 right here and 45 right here. Calculate that baby to 1 hour and 42 minutes. So this is saying that you have 1 hour and 42 minutes worth of fuel on your aircraft. Okay, guess what? More information. Denver. All right, Denver's elevation. What was it? 5434? I think. Yep, 5434. Salt Lake, 4231. Oops. I'm just going to put that in right now. 4231. Okay, takeoff runway in Denver, it was 16 right. Takeoff alternate, we didn't need one. Now we get into these V speeds here, okay, for our takeoff. And then guess what? Our takeoff stab trim setting. So really quick, I'm just going to put landing runway over here for Salt Lake with 16 left. We're going to get our landing speed. We didn't have any alternate for our destination. So now we get to go into the V speeds, and we find the V speeds in the performance charts. Okay. So we're going to come back to the performance charts, go back to your table of contents, and now it's number 4, takeoff and landing speed charts. So this is what they look like. Okay. Now, this specific one is for 57,000 pounds or less. This top half is for takeoff at 57,000 pounds. This bottom half is for landing at 57,000 pounds. Okay. Well, what we need is our takeoff V1, V2, and VR. So our takeoff weight, our actual takeoff weight that we just figured out, 64,052. So we're going to go find 65,000 because we're heavier than 64,000. 63, 64, and 65. So this top half is for taking off at 65,000 pounds. All right. All right, takeoff flaps. You have either 8 or 20. We always just keep it at 8 for consistency. All right, now we have this little table for V1. Okay, this table right here for V1. This top line to pick our column, we need just go to the elevation. So taking off from Denver, Denver is 5434, right? You're higher than 4,000, so just go to 6,000 right here. And then our temperature that we're planning. Well, we were planning on 18 degrees Celsius, okay? So we're hotter than 10, so we're gonna go to 20 degrees and 6,000. So there's our V1 speed right there, 127. I come back down here, sorry. Okay, 127 right there. Okay, our V2 and our VR. Pay attention to what you're looking at because the second table right here is actually for VR. It's not V2. So our VR right here, same process, the 6,000 column and then 18 degrees. Our VR is 127. So VR right here. And now V2 is this next line down. So V2 is this first number. Don't worry about the go around. Okay. GA is for go around. V2 right here, 136. That is our V2 speed. Now, really quick, before I get out of these speeds, okay, the speed charts, I'm going to find landing speed for Salt Lake, landing speed into Salt Lake. Our landing speed, we're going to need our landing weight that we just figured out, right? That was that 60,482. So guess what? We're going to go find the 61,000 pound chart because we're heavier than 60,000 pounds. So 61,000 pounds, again, this first half is for taking off at 61,000. We're going to go to the bottom for landing at 61,000. We are going to come over to this VREF right here, our velocity reference right here. We're going to come to flaps 45 degrees, and our landing speed is 128. All right, takeoff stab trim setting. In your performance charts, again, takeoff stab trim setting is number 5 right here. Okay, remember it's for takeoff. Okay, you have 2 tables on this page, flaps 8, flaps 20. Again, stay with flaps 8. Now we need our back to our takeoff weight, right? And then on this side is our Mach percentage that we figured out with weight and balance. So remember, our takeoff weight was 64,000 and a tiny bit extra, right? So we're heavier than 62.3. We're going to go to 65. And then we're going to come down to our Mach percentage. Our Mach percentage on that weight and balance sheet was 23%. So we come down to 65,000 column and come down to 23 right here. And it is 6.9. That is our takeoff stab trim setting. Oh, I went too far. There you go. 6.9 right there. All right, the very last thing, this V1 speed of 127. Remember, I skipped that box on the very, very first page. for this max V1 right here. And 27. Guess what? We are finished with flight plan 1. We go back up to the front. Okay, flight plan 1. We have everything filled out on the front of our release, our dispatch release. Now, electronically, it will have your name on there as your signature, and the pilot and commander, the captain, is going to sign it off as well, and they will electronically sign it. Okay. We did our IFR flight plan with all of our performance numbers. And that we do this to find our actual fuel burn and our actual time, because then we get our actual takeoff weight and our actual landing weight. We did our weight and balance to get our estimate numbers and to make sure that we were balanced enough to take off. And we filled out our performance worksheet, just more information about our burn and our runways and our airports and our V speeds. We filled out this takeoff, destination, and alternate requirements form. More details about Denver and the runway that we are going to use with the takeoff minimums. And then also Salt Lake with the runway we're going to use with the specific approach that we're planning on. And then, of course, our pin chart to figure out our index for our passengers. Okay? How do you guys feel? You overwhelmed? You just finished flight plan 1. Congratulations. Everyone should feel great about that. You don't have to do that ever again.
It took us 2 days.
It took you 8 hours. Congratulations. It did. It took you 8 hours to do flight plan 1. Guess what? You're going to get so much good practice with these flight plans. You're going to get it down to about 2 hours. Okay? Trust me. Trust me. You'll get it down to about 2 hours. All right? But now you are officially finished with flight plan 1. Hit me with your questions. Hit me with your feelings. Does anyone have any emotional outbursts? Not yet.
I liked it. It's logical.
It's kind of nice to see how everything comes together, right? Because guess what? During Legal to Go, we were talking about FARs. We were talking about landing minimums, being able to land at our ECA. We were talking about the 1, 2, 3 rule, if we needed an alternate or not. We talked about if we had any MELs. So we're now, talking about systems. We were talking about meteorology, of course. You always talk about meteorology. But you're talking about all these things that you guys have been learning over the last 6 weeks. And now with flight planning, you're bringing it all together. That's why I like flight planning so much, is because everything that you've been taught over the last 6 weeks, you're just bringing it all together. That's all we're doing. Okay.
Is there weather on future flight plans like this, or on the practical that we'll have to route around?
We start to introduce you more to different weather scenarios. So you will see more weather impact on your flight plans. Obviously, this first flight plan, since it's just a basic introduction, we don't, hit you with really bad weather or anything like that. But you will get flight plans with a lot worse weather. What else?
So, we hear about the dispatch release and the flight plan are technically 2 separate things. Is what we just completed is that just kind of the two of them together?
Uh-huh. Yep. So you had your flight plan briefing packet. That was all the information with the METARs and with the, all the information about, your specific flight. And then we went into the dispatch release and we actually planned the flight. Okay. So each flight plan that you do, you're going to have your briefing packet that gives you all the information about your flight. And then you're going to fill out a dispatch release to actually plan the flight. Okay.
And one more question. The little drawing you did for us to figure out our cruising distance.
Yep.
Are we going to need to have that drawing on there, or is that just for us to figure out that those cruising segments?
You don't need it on your actual dispatch release, but you will be either drawing it or utilizing that guide with every one of your flight plans.
Okay. But technically, and I'm talking about the flight plans we're doing for, in class.
You don't need it like
We're not going to
on
need
there.
the drawing.
Mhm.
Okay. All right, cool.
No.
Thanks.
No, because you guys, I highly recommend bringing a notebook with you, because you'll just be taking notes and you'll be writing down all of this different stuff, right? You're going to be doing ISA calculations. You're going to be doing all of these different things. And so bring a notebook with you. We do have blank paper, but it's just, blank copy paper. It's not lined paper. So bring some lined paper, just a notebook with you. But yeah, you guys, seriously, this is why Jaden posts what he posts, to just say, hey, this is an introduction. Don't let yourself get overwhelmed by the end of it, because like somebody said at the beginning, I can't remember who it was, it felt very saturated last night. And I said, guess what? At the end of tonight, it's going to feel even more saturated, right? It's just a ton of information. But none of us expect you to remember any of it tomorrow. Okay. We do not expect you to remember any of it Monday. So tomorrow is your big review. And so focus on that. Okay. Focus on your review tomorrow. These last 2 days were simply an introduction to flight planning. Okay. Just to kind of get an idea of what we're going to be going through during in-person. All right. Any other questions? Any questions about St. George? You guys have the address, right? The address to the school out by the airport. It's not at the airport, it's by the airport. And you actually go past the airport. You keep on going on that road, and then you're going to turn left. You go past there. There's a little museum as well. You go past the little museum. So it kind of feels like right in the middle of all the hangars. But just that millionaire FBO out there. What else can I tell you about in person? Somebody texted me about a dress code. Casual. Okay. You guys can dress casually and comfortably. It is going to be in the 60s here, but guess what? It tends to get a little chilly in the FBO in our classroom. So just be aware of that. Also, we set up job shadowing for you guys at SkyWest for anyone interested. You don't have to be interested in working at SkyWest, but you can just go to the job shadowing to see how it is. We recommend just wearing something kind of like business casual to SkyWest if you do job shadowing. And then also we have SkyWest Dispatch Management come out to the class to talk to you guys. So if you are interested in working at SkyWest, guess what? You have the management coming out. So if you want to wear something a little bit nicer when they come out, that's up to you. And then for your practical, right? The Dades aren't going to say, oh, you are wearing jeans, you can't wear jeans during your practical. Okay, they're not going to say that. But some people prefer to wear a little bit nicer stuff when they take the exam. So again, that's up to you. You could even just wear your school shirt. So we're going to have a shirt for you guys out there. You could just wear your shirt during your exam if you wanted to. You didn't want to have to worry about bringing nicer clothes. You can wear your shirt to job shadowing when SkyWest comes out to the class, whatever. Okay. But yeah, just casual. That's our dress code. Some people, if you are a cold person, we've had people bring blankets out with them just because they get cold. Okay. So just be aware. I just want people to be aware that it does tend to get a little bit cold in the classroom, even though we try to keep it a comfortable temperature. But anyway, any other questions? Anything that you can think of? Nothing. You guys are so quiet. We're going to break the ice with you guys. We really, really are. You guys are so quiet. You guys are just going to get to know each other as well. You're just going to break the ice yourself. But yeah, it's like, do you guys have any questions about Monday? Class starts at 5:30 on Monday. So and then every day after that, it'll be 1:30. But just that first day is 5:30. So really no reason to come out earlier than like 5 o'clock. Okay. There's not many food options close by. So bring some snacks if you want to bring some snacks. We do try to have snacks on our little back table that we have in the classroom. We have 2 offices out there by our classroom, one of which has a refrigerator in it, and we try to fill most of that refrigerator with drinks for you guys. So if you have any particular requests for any type of soda, we have, of course, we'll have water, but we tend to stick with the more popular soda. So, Coca-Cola, Mountain Dew, Dr. Pepper, Sprite, stuff like that. But if you have any requests, please let me know, and we will do our best to provide something. Okay. But yeah, we try our best to just keep snacks out there for you guys. But Monday, so class starts at 5:30. We'll do introductions, just a quick introduction for everyone. Just because it's like you guys are meeting us in person, we're meeting you in person, and you're meeting each other in person. So it's really just a quick introduction to remind everyone who each other is. And then after introductions, you'll just take your quiz, your final quiz, and get that over with. And then we'll jump into Flight Plan 2. And that will be Monday. Okay. What else? We feed you dinner on Tuesdays and Thursdays, just so you're aware. We'll get dinner for you guys on Tuesdays and Thursdays. And I can't really think of anything else. So if you guys have any questions, let me know. But other than that, we'll be finished. So I'll stick around. I'll stay on for a little bit longer if you guys have any questions that you want to ask. But congratulations on getting Flight Plan 1 finished. Class is over. Go to bed. I'll stop recording.